My role here at Autodesk is to support our construction customers through the life of their experience working with a wide array of our tools, and I have the honor of being the host and moderator for today's discussion. I'm also excited to welcome everyone to our innovative Autodesk Technology Center here in Boston. You are actually going to be able to have a tour today and get a closer look at some of the amazing technology and projects that are being produced down in our tech center. So when Cindy and Hamish and the Howick team told me that they were coming to Boston, I was like, oh, that's wonderful. There's so many amazing people in AEC here in the Boston area. And while that does happen to be true, it turns out someone told Dion about the foot-long lobster roll at the Legal Seafood, and that's actually the real reason that they decided to come all the way from New Zealand. We have an amazing selection of presenters and programming this morning, including an example of what it looks like when AI becomes a client. Down in the tech center and visible right there from above, you'll notice a structure of prefabricated shapes designed by LA Design Group, constructed by Windover using the Howick machine along with Studio IO stud finder software. It was informed by ChatGPT prompts. So in the spirit of AI infiltrating everything that we know and love, I asked ChatGPT to write me some jokes about industrialized construction and the Howick machine. I'm going to tell you right now, these are terrible. So, but we're gonna see what ChatGPT had to say. So here we go. And in my best Jerry Seinfeld opening, what's the deal with industrialized construction? It's like building with high-tech Legos, but with a lot more power tools and fewer tiny bricks to step on in the dark. So for any parents in there, you know what that's like. And let's not forget the Howick machine. You know you're in the presence of true construction geeks like all of you when we gather around the Howick machine like it's the latest celebrity, asking for an autograph made of precision engineered steel. So thank you very much, ChatGPT. I think our AI overlords still have a long way to go when it comes to creativity and at least when it comes to jokes. So now I'd like to go ahead and actually introduce a little bit more about Howick. Howick is a pioneer in precision light steel roll forming technology, and for over 40 years, the company's commitment to innovation in light gauge steel, precision manufacturing is uncompromising, and exemplary customer service has defined the Howick way. As a manufacturer, over 95% of Howick's products are exported overseas from New Zealand, with the bulk servicing the construction sector in the US, UK, Canada, Ireland, and the EU. The business has been recognized many times over, most recently in 2019 as the Export NZ Awards New Zealand Midsize Exporter of the Year. Howick has enjoyed consistent growth since day one, yet it has seen demand balloon in the last 5 years as the uptick in modern construction methods has exploded to meet global needs for affordable quality housing with more efficient, sustainable ways of building. Autodesk, similarly, is very proud to support and partner with Howick. We're so happy that they're here and they decided to host with us today. Autodesk's mission is to empower innovators with design and make technology so they can achieve the new possible. Our technology spans architecture, engineering, and construction, product design and manufacturing, and media and entertainment, empowering innovators everywhere to solve challenges big and small. In 2018, Autodesk announced that construction would be a key focus area for the company's future as a design and make company to help make construction more predictable, sustainable, and safe. Autodesk offers products that cover the entire construction lifecycle, from design through pre-construction to build and operations, and it's responsible for the products within Autodesk Construction Cloud. Now, to tell you a little bit more about Howick and the Steel Horizon series, I'd like to introduce Cindy Posimani and Hamish Coubray.
Welcome, everyone. How are you? We're so pleased. Oh my gosh, it is full. All right, I've got this lovely script that my agency wrote for me. I don't think I'll read it to you too much, but we do believe in thought leadership, and we do believe in collaboration in this industry. And we believe in innovation, which is why we're partnering with Autodesk. And we want to thank them again for being so supportive for this event. Without them and without this wonderful venue, this couldn't have happened here in Boston. So thank you very much again. Just want to say something about Steel Horizons, and because this is written so lovely. Steel Horizons come about from our desire to inspire change by providing access to insights and case studies from organizations and people that are using modern construction technologies and processes to share and showcase the work that they've been doing. So we started our series last year in London, and that was our inaugural event, and it happened despite the national rail strike that just basically nearly floored us, but the attendance on that day was such that extra seating was required. So we were very grateful and very heartened. And many guests literally went the extra mile to come to our event because they couldn't take the train, and train was very important for travel in the UK. So we're very privileged to have our speaker lineup today, and every one of them is an expert in their realm, and they're going to share with you amazing insights. So we are very grateful that every one of them that we approach, they say yes straight away and go, yeah, we would love to help and we would love to contribute. So thank you again, and have a good time. Learn heaps, okay? Socialize heaps. I see that you're socializing already, and enjoy your day. And I'm going to pass the time over to Hamish. Thank you.
Hello everyone, and welcome to Steel Horizons 23. It's great to have you here, and I'd just like to welcome everyone who's come from a short distance or overseas. We've got a lot of different people here. And I'll just speak a little bit about Howick before we get started, if you're not familiar totally with us. So we are a third generation family business. My father and grandfather started Howick about 43 years ago now, and now my brother and I are involved. And the whole company is like a family. You can see up here, this is our traveling family we move around with and see you everywhere. And I'd like to thank Autodesk for hosting this event. We've been really fortunate to have a great partnership with Autodesk here in Boston since 2017, when we first brought our 3200 framer machine here, and now we have our telescopic 3600 machine. And it's just a great space to come and share, people to come and do proof of concepts, develop different ways to use the machine, build interesting towers, as you'll see later on today. So yeah, thanks so much to everyone at Autodesk for hosting us and looking after us today. And I'm sure everyone's going to get something great from all the speakers. There's going to be some interesting stuff. So thanks a lot.
Thank you so much, Cindy and Hamish. So, as Cindy described earlier, today's program is about bringing together some of the most influential minds in industrialized construction from across the built environment. They're going to be talking about what's happening today on the ground, as well as what's about to come in the next horizon. We have 8 visionary speakers today representing the diverse set of experience across the construction lifecycle. You'll walk away from today's presentations with a broad perspective on the evolution of the industry in the US and beyond. Let me introduce our first presenter. Dave Cooper is the co-founder and host of Dave Cooper Live. Dave is a super connector in the global industrialized construction sector who has built a multimedia highway of case studies featuring industry leaders who drive business forward. As host of the live streaming Dave Cooper Live show, he has interviewed close to 2,000 professionals in the ecosystem of the built environment, including the largest construction companies, C-suite executives, fabricators, supply chain experts, and startups. Dave is a community builder where membership is inclusive and viewers are encouraged to participate in the conversation. Dave has spent the last 5 years touring smart cities, net zero master planned communities, manufacturing facilities, skills training academies, job sites, and more, seeking out the emerging building products, technology, and advanced building processes around the world. His award-winning work has been featured in dozens of outlets, including the Wall Street Journal, Bloomberg, and Forbes. Before becoming a custom home builder, Dave served as a combat medic in the US Army. During the pandemic, he took the Dave Cooper Live show on the road, living full-time in a motorhome with his wife and 3 children, that is a feat, as they traveled throughout the United States. Please welcome Dave Cooper.
All right, welcome. Thank you, everybody. We can't have any of the collaboration and grow our community without all of you. So thanks for taking time out of your busy schedules to come here today. Howick Autodesk, thanks for hosting. So as you can see, I had to cut this down from like 50 slides to 32. I got a lot of notes. I'm going to take you on a whirlwind tour of what it's like to be in the world of Dave Cooper Live. So today we're going to talk about megatrends, and there are plenty of mega people talking about the megatrends that are out there. So with that, we are going to be talking about how businesses expand their global footprint, and they are getting laser focused on local strategy, paying attention to cybersecurity, national security, sustainability, and resilience. So today with that, we're going to be sharing just a small tidbit of what it's like maybe in about a week of my time interviewing people from around the world. And many of these people are talking about mega trends. And yes, I am going to talk fast. If I'm going too fast for you, I think Jim Gabriel said, or somebody said, raise your hand. I'll try and slow up, but I got a lot to cover. So with these megatrends, we have people talking about climate change, technological disruption, demographic shifts, as well as fracturing worlds and social instability. So most of us in this room are building buildings where people can thrive, not just to survive. And I think that is so important as we move forward in this conversation. We're going to start off with Bryden Wood today, the Forge. This is in London, and this is a massive example of addressing megatrends with a local solution with practical applications such as productization and standardization. This building was designed and constructed to be deconstructed, and that is delivering to the promised circular economy that we all believe in. If you want to learn more about what they're doing, they have the Construction Innovation Hub as well as the platform rulebook. So check them out. Maybe you're not ready to build something so big. Well, how about this company? We can reduce, reuse, repurpose, and recycle. They are using robotics and AI to remove wood, the nails, the screws, the staples from lumber. It's analyzing the lumber, it's cutting out the bad pieces of the lumber, and then you can reuse it right away on your job site. This is a mobile application. So think about if you're tearing something down, you want to have this here, and you can reuse it locally. Now, maybe not such a big deal on paper, but Timber HP, American-made, renewable, biodegradable, non-toxic wood fiber insulation. Big deal. It is a big deal, and I'm going to tell you why. Because this is being used around the world. Guess what? Finally, somebody here, just north in Maine, has brought this product to market, and it's something that we should all be looking at because it is a sustainable solution that we can all be using. Watching the grass grow. That's a cool factory, right? That's not a rendering. Watching the grass grow. So a bunch of SpaceX engineers ask themselves a simple question: what's the fastest way to pull carbon dioxide from the atmosphere and lock it away? Their answer: cultivate the fastest growing grass on Earth and invent new production technology, starting with panels made from grass. That's a real factory, and they are doing it. They have come up with the fastest perennial growing grass ever created in the world. And they also recently partnered with D.R. Horton to come up with other building products. What if we mixed wood with concrete, right? Then you would have the Ascent building. This is a 25-story luxury apartment building. It is the world's tallest hybrid mass timber structure built in Milwaukee. Now, 19 stories of mass timber, over 6 stories of concrete with a concrete core for stability. The project manager on this, I want to give her a shout out, is Taylor Cabot. She is definitely one to watch, so look out for that name. This is one of the projects. She has done several of these now across the United States. What if we mix wood with technology? Then you would come up with Mercer International, who is a global forest products company with operations in the US, Germany, Canada, and Australia. And they've also just acquired the Katerra plant. Raise a hand, who heard of Katerra before, right? Well, there's a lot of assets out there, and they actually were the ones that bought the CLT plant out there, and they created Mercer Mass Timber. They're growing even further. They actually bought Structurlam as well. So with all that, they are focused on building products and solutions for high-performance, low-carbon buildings. This stuff is real. It's happening. British Offsite. Who believes in crawl, walk, and running when they're doing their business, right? Show of hands. It's usually the best way to go, and they are ones that have proven it. So Weston Homes tested panelized construction with subsidiary British Offsite before opening. It's roughly, I think, 175,000 square foot new manufacturing facility with a zero labor line from Miranda. What's important about this? They gave Sean Weston, third generation, upcoming CEO of the company, a small space in the warehouse because he said, I can do this better. He created a panelized system, and it's not just a simple panelized system. It's a cold form steel panel, fully insulated glass, and the way they put it up is amazing. They can be building on the second floor, and people can be moving in on the first floor. That's how fast it is and how they've increased the production. So let's move on to FortiPro and Samsung. Who knows Samsung? Raise a hand. Technology, right? How many people knew that they're actually one of the largest, if not the largest, general contractor in the world? Everybody's seen the building in Dubai, the real tall one? Yeah, that is Samsung. Well, they have just formed a partnership with FortiPro, and they plan to launch and operate modular construction factories around the world. Let's say you don't want to go around the world. Let's say you don't want to be global. Let's say you want to be local. Well, as Cubby calls it, we're going to serve the glocal economy with a G. All right, so delivered by QB, their plan is to deliver turnkey transportable factories close to the job site, and they're going to build cities in days, not years. An early mantra of ours was connect, grow, deliver. Some of these folks are actually in the room right now. And Modlogiq, Design Logic, Jim Gabriel's out there. You should check them out. I saw Roger Krulak. You know, they have a partnership now from Full Stack Modular, IQ Modular, Rengley, you know, P4 Collective House. These are companies that are expanding and using the crawl, walk, run approach, and they're partnering with other companies, or they're growing new companies within their companies to take it to another world. Why is this important? We always hear about the headlines that report the crashes and the failures. But if you look around this room, you might be sitting next to your future coworker, future collaborator. You just don't know, maybe even a partner in your business. SWS panels, and you can look at the numbers up there. This is a friend of mine, Diego, out on the West Coast. Diego Rivera, he has the best quotes ever, and I want to share them with you. He says, more sweat, less saliva. Trust your process so you can trust your people. He also often says, digital transformation is a tool, not a strategy. He does talk a lot, but the proof is in the numbers, for sure. California-based SWS Panels is fabricating panel solutions for the industrialized construction market. And what else did he do? He created his own design fabrication software, and a lot of people want it. Guess what? His software, you don't even have to speak English, German, Polish, it doesn't matter. It's color-coded. Anybody can come work for him and build those panels. It's an amazing operation that they run. Let's continue on software, right? Let's talk about software that benefits people and the planet with Modulize, who believes that offsite construction is humanity's best answer for tackling one of the biggest sustainability challenges facing the world today, the way we build. So we can read Modulize is a procurement platform for constructors and manufacturers that provides automated takeoffs, cost estimation, collaborative tendering, and bid generation. This one I got to read verbatim coming up, ARCs. Anybody in here heard of ARCs before? Well, you're not watching my show. You should be watching the show. All right, so listen, ARCs. AI-driven real estate analytics platform that automatically underwrites the future potential of millions of properties in advance, enabling developers, investors, and agents to source and evaluate optimal investment and development opportunities in seconds. So all that financial modeling you're doing, all that due diligence that normally takes dozens and dozens of hours and done by highly paid professionals, this just leveled the playing field so that developers who don't have access to the talent can lean into this software, understand the regulatory and market forces of that area, cut costs and time, and actually build something in places that desperately needs housing. And they say it best. ARCS is on a mission to catalyze the development of an equitably built world, bringing technology, social equity, and sustainability together. This is another example of cutting waste. The wasted time, the wasted resources, and figuring out if a project will pencil. This is a cool thing. You should write it down for sure and check them out. And you can understand why I had to read that. That's a lot to get right. So let's talk about technology. The smart factory of the future includes Industry 4.0 and IIoT, the Industrial Internet of Things, technology to reach full factory potential. So the future of work. It includes ensuring the quality and safety of our employees, right? Smart connected factories can streamline the production processes and increase overall efficiency. Anybody ever see this guy? Buckminster Fuller, right? Gotta love it. So he really does say it best. You never change things by fighting the existing reality. To change something, build a new model that makes the existing model obsolete. Now, we all know change is hard, and nobody likes change. Fewer of us want to change. So why would anyone really want to shift from traditional site-built construction to prefab? Is it convenience of the megatrends and how the industrialized revolution can actually change many of the ways they think? So we got climate change, technological disruption, right? Demographic shifts, fracturing worlds, social instability, all of these things. And this is one of my favorite slides as well from Steelbox, right? No one wants it if it's ugly. Nobody. I don't want it if it's ugly or if it's poorly designed. Solving for affordable housing with design and construction solutions that people can be proud of. That is one way to leverage the power of prefab and embrace social equity. Give people things that they'd be proud to live in, right? Sustainability and profitability. So, who's going to build these beautiful things? Get your pens out. This is a good one. Anybody hear of Stacks and Jewels before? Love Stacks and Jewels. There you go, back there. So, Stacks and Jewels is a project-based learning, job placement, and career development program dedicated to positioning tech-marginalized youth and adults to fill critical labor shortages in the building automation and energy management systems industry. They are a nonprofit workforce development program, and they are working in overlooked populations. That is awesome. Who else is building it? Navy SEALs. Imagine building your house while you're getting deployed all the time. You're in a combat zone, and they're dealing with site contractors. They said we had enough. Agorist actually brought in technologists. They opened a factory in Southern California, and they are building houses today. A bunch of Navy SEALs. I highly suggest not ticking them off. They also like to work with NASA, too. So they're working. And if they work with NASA, you'd have more Navy SEALs. This is bot built, and they're doing amazing technology to make housing more affordable. That's right, NASA is in on this as well. Who has the coolest neighbor in the world? This guy, right? You walk outside, and there he is power washing his house, you know, with drones. It comes to find out that he's also very big in the agricultural market as well. Think Super Bowl, you know, stadiums, post-COVID eras that we live in and having to sanitize things. That's what they're doing. Guess what? He opened his garage door. He has a self-built autonomous flying car in his garage. He graduated from 3rd grade only and left the Amish community as a young person. He has the desire to develop solutions for the problems that he's seeing surround him. That's cool, right? This is a cool one. I know Autodesk is already going to like this one. Meet IronBot and TieBot. They are cutting the installation of rebar in half. That's right. Not 70%, 50%. They're cutting it in half, not 25%, I should say. So with that, they are starting to show the future of what robots in construction can do. And it doesn't take jobs from people. It allows these guys, instead of hurting their legs and their knees, to be working on more important things while they're out there. So what does the modern, materials look like? This is GeoShip. Anybody see GeoShip before? Right? They're making bioceramic domes. They believe that these fireproof, hurricane-proof geodesic domes are the post-climate change house of the future. World of smart homes. This is cool. They're taking old school technology, clay and bricks, and they are making panels from them. And not only are they making panels, I'm going to read this to you. They're offering fully automated manufacturing of prefab walls made of bricks, aerated concrete, and sand-lined bricks. The system integrates existing prefab technology for the highly efficient installation and operation of these homes. The most sustainable building ever to be built is the one that does not have to be built again, right? That's what they believe in. These walls integrate all the wiring harness, prefab stairs, exterior cladding. You want to check them out. We're almost done. Vantum. Anybody hear of Vantum out there? All right. Vantum's coming on fast. They're coming out of South America. They just bought Affinity Building Systems, and they are backed by Breakthrough Energy. Well, who's Breakthrough Energy? Who's Breakthrough Energy with, right? That's Bill Gates, Jeff Bezos, Richard Branson, just to name a few. And they are known for their panel technology, which is cementitious board that's resistant to fire, moisture, insects, and mold. And they have a formula for building net zero energy efficient structures. And they are looking at doing 1 million square foot worth of factories. 20 of them coming up soon. All right, 3D printing. I'm going to cut it off here in a second. 3D printing, we got to talk about it. It is making a lot of ground and a lot of progress. We are finding them traveling the world in underserved areas where you don't have Lowe's, you don't have Home Depot, and they are testing the soil everywhere they're at so you can use the local resources and not have to ship it around. They're also working with NASA and Moondust. My last one. Who knows this building? Yeah, right. That's the Apple Park office building. Who knew that Clark Pacific, this is the largest structural precast building ever built, they think. 2.5 million square feet of panelized structure, the Apple building. So Clark Pacific has did the architectural and design on these. Where can you find all these resources, right? They're sitting here in the room next to you. So all of the conversations that we have around the world are informed by all the people sitting in this room and others. So we can't do what we do. I'm a megaphone for the industry. You guys are doing all the hard work out there. You're putting it together. My job is just to share that so we can all collaborate and come together. So we have people like Marty Corrado. I don't know, is Marty here today? He's not a mega trend, but he's definitely a mega personality. Jamie Johnson, Phil Langley, the folks at Brydenwood, and then you got, Trudy Solly, Martin Fenn. There are people around the world that are willing to share their knowledge. Amir, you'll be up here talking as well. So with that, all I can say is these people in everyday conversations talk about climate change, technological disruption, demographic shifts, fracturing world and social instability, and they're fighting hard to tackle the digital waste so it doesn't lead to the physical waste. Thank you, Amy. That is your comment, and I took it from you. And thanks to all of you. So listen, please keep inspiring the next generation to follow in your footsteps. Become a mentor to the next generation. Open the door for them. Listen to them. Support them on their journey, because if you look around this room, we need the younger people in this industry, and we can all make a difference and make it happen. Thank you. That's a lot.
We have a moment. Are there any questions for Dave? Anything that came to mind? Otherwise, I do have one. All right. So, Dave, you've been to thousands of job sites now, thousands of manufacturing facilities. You're seeing massive, examples of industrialized construction happening everywhere around the world. One of the things that we still know is still a challenge in our industry is sort of that cultural mind shift, right, around and really embracing these new ways of working. Do you see it changing?
I do see it changing. In fact, I see it changing faster than it has before. With the lack of skilled labor, the legal lawsuits that come out of using unskilled labor, and I think a lot of the bigger builders, globally are starting to realize, the value of offsite construction, right? It's not about how do we do less, right, with more, or how do we do more with less is what they're all looking at. We're not taking jobs away, we're creating jobs in what we do. And I think, as I look at technology shifting, and I look at like so many people out here that are saying, all right, this technology already exists. How do we use it in our business? That's the key to all this. A lot of this stuff we don't have to reinvent. We just need to use it for our own industry. So I don't know if that answered your question, but it is changing, and I think, you can tell by the amount of people in this room.
Absolutely. So the liminal point is here. We're there. I love it. Thank you so much, Dave. Really appreciate your time.
Thanks, everybody.
Great. Our next speaker today is Brandon Ionata from the StrucSoft. He's a senior director there. Immersed from a young age in the built environment through his family's construction business, Brandon has leveraged that life experience into his professional career at StrucSoft over the last 11 years. An expert at enabling customers to bridge the gap between design and manufacturing, Brandon leads the StrucSoft team as they push the boundaries of 3D BIM workflows, development of Revit add-ons, and bespoke custom programming projects for wood and light steel framing. Brandon is a family man and father to his 2-year-old little girl and stays connected to his hands-on roots through hunting, fishing, and restoring vintage Harley-Davidsons in his spare time. Please welcome Brandon Ionata.
So good morning, and thank you for the introduction. Thank you, Dave, for starting this off or kicking this off for us. Always a hard act to follow, especially a guy out of the software side of things. Following a guy like Dave is a tough one, so I'm going to do my best. Hopefully everybody bears with me a little bit. Fantastic turnaround. I really have to thank Howick, who've been excellent partners over the last almost as long as I've been at StrucSoft, for the opportunity to speak to everyone here today. So today I want to talk to you a little bit about BIM in the workshop. It's something that we focus on very much at StrucSoft, and I'm particularly going to be discussing how software plays a major role in this ecosystem of prefab industrialized construction, and how things are changing with the adoption, or how things have changed, I should say, with the adoption of tools like Revit in the industrialized construction industry. Obviously, Revit is not a tool that we would immediately assume is a fabrication tool, but I'm here to talk to you a little bit about how it is and how it's being employed today in the industry. So before I go too far, I want to just give you a little bit of background about our company StrucSoft and the company that we've become over the last few years. As mentioned, I've been involved with StrucSoft for over a decade, and the company really started out as a small reseller based out of Montreal, where I'm from. And we first provided software services and customization, as well as the software itself, for this industry by way of HSB CAD and ProSteel. So back in 2007, we started our development journey of developing what we believe is the first commercialized Revit plugin called MWF, or Metal Wood Framer. And Amy Marks mentioned that she had actually purchased one of the first versions and had to install it from a floppy disk back in the day. So it's a great piece of history, I think. If I get my hands on that floppy disk, that'd be something. We'll put it in put it up on the wall. In any case, MWF is an automated light steel and wood framing tool for Revit. Okay, and since then we've basically been focusing primarily on improving MWF, building our user base, as well as building customized software solutions around MWF and Revit. So you can imagine that this has kind of brought us into many accounts where clients were either starting to assemble the necessary parts and pieces for prefabrication or industrialized construction, or other accounts who have already been through that process and are really seeing a deficiency in the software that they're currently using. So they needed help in modernizing. So now a little over 2 years ago, we were acquired by Graytech, one of the top 5 Autodesk resellers globally. And it's been an excellent match because at its nucleus, Graytech is actually a software developer, first having developed advanced steel and then advanced design. So the collaboration has really bolstered the StrucSoft business and been able to help us provide better services and better solutions to our customers in the industrialized construction industry, as well as really leverage their experience in engineering and analysis of structures. So hopefully we're going to see, full, complete light gauge steel structural analysis in Revit sooner than later. So we'll get back to what I really want to talk about, which is kind of Revit as a data source, as a fabrication tool for this industry. So at StrucSoft, we recognize very, very early on the power of Revit. Okay, specifically parts of Revit that are crucial to using this platform as a basis for manufacturing or fabrication. So the most important in my mind is the precision that Revit basically is built into Revit. Now, even though a lot of people using Revit do not fully embrace the precision of Revit, it's there and it's perfect venue for fabrication where precision is key. So as most of the people in this audience know, all the precise data can be built into families relating all matter of material properties, and of course accurate dimensions, engineering aspects of those studs, for instance, the steel that we're using for the Howick machine, as well as weights of materials so that we can look at how things are affected downstream. So all of this information is contained within the Revit project, which we look at as programmers as a massive database for which we can basically build software to call on each bit of that data and manipulate to produce very, very precise machine code to automate manufacturing through machines like Howick's, as well as assembly machines, which are going to help us put together those panels downstream. So how does it work? Obviously, this is a very simplified workflow to how things actually work, but let's use it as a the premise for this discussion. You know, models are never 100% precise, and I hear this all the time from all of our customers. They're getting something from an architect, and it's barely usable from a fabrication standpoint. So we need to accept that we're going to see these workarounds, and we're going to see plain bad drafting in the industry. However, you know, through trial and error, we've seen that this workflow is one that works day in, day out for most of our customers. The first part of this is to take that source data and to create what I call a structural model. So a structural model is where we really start to clean up the model. We build in that precision, into our structural model. Now, the power of Revit obviously is that it's a sandbox, and we can link in our structural model to that architectural model for clash detection and all the, you know, those fancy buzzwords that we hear all the time. But these are fantastic tools for the fabricator to use. So we're able to essentially pull out all of that data and send it downstream. Next part is creating the fabrication model or the framing model. Sometimes the structural model and the fabrication model are one and the same. And it also varies depending on what our end product, you know, could be. Frame wall panels, not to put anyone down, is probably one of the more simplistic outputs that we're seeing today. Obviously, we start talking about wall panels which are fully enclosed, including all manner of you know, interior things such as insulation, vapor barrier, but also MEP. And of course, we're also looking at volumetric outputs, right? So I'll talk more about the shop documentation and fabrication aspects of this a little bit later as we get a bit further into the discussion. So let's discuss the precision for a moment, okay? In the world of fabrication, this takes on an extremely different meaning. We understand that the precision of these machines is far greater than your typical construction tolerances. We're talking, you know, millimeter precision, but also far greater than obviously your typical precision found in your day-to-day Revit model. So it's a huge benefit. But we have to be careful that this, it can become an issue essentially down the road if we do not pay attention to our source data. Again, that source data is Revit. Revit is a data source. It can be super precise. So really, it makes no sense to be exporting, this data to additional sources. You know, we want to use the Revit sandbox, and we advocate, you know, doing this level of detail, this level of framing directly in the Revit model. You know, this is why we advocate, you know, framing in Revit. If you see a little bit of a clip of a model here. Obviously, a very complex model with, you know, hangers for MEP, obviously multiple collisions in there, as well as through wall MEP, which is all stuff that we want to see downstream in the fabrication model. So the question becomes, how do we translate this information to the shop? There's several ways that we do this. And the other question is, do the people in the shop or managing the shop need access to the Revit model? So it's a really good question. The answer a few years ago might have been yes, to some degree, but you know, we'll see how software has really changed that and made that idea a little bit obsolete. So there are obvious and less obvious ways that we're sending data to the shop. Obviously, you know, paper is still king. We're sending over, you know, shop drawings. It's an integral part of what we do. But less obvious ways are laser layout tables. So Dave's presentation, he showed us Vertec lasers. This is one that's widely used. You see this a lot in truss shops, but you're starting to see it more and more for panel layout tables and so on. And then clients are starting to become more and more interested about leveraging this data downstream. So of course, we're seeing QR tagging and even RFIDs being used to kind of track production all the way out to final delivery. So back to shop drawings or panel tickets, it's really a necessary part of the puzzle, okay? And this is where historically most companies are putting the most time. So what we've done is really thought of ways to automate the creation of this directly in the Revit model, because this is a really important part for our ability to clash detect, as well as, you know, start to develop the data necessary for fabrication. So nothing glamorous about a 2D drawing. Like I said, super necessary. The ability to create one of these every part of the panel is really, really important. You can see some of the detail that we have in this model, from dimensioning all the way out to full bill of materials for every portion of that panel. I don't have any examples of it, but if you have sheathing, MEP like we have in this one, all of this information is placed in the model. And what's really nice is it's all parametric. It's all parametric, it's all live, the data lives in the Revit model. This becomes our source of truth for our fabrication project. So here's where things really start to get interesting, I find. So I guess as we begin to take on more offsite builders as customers and as partners, we started to see that some of the data that is super critical to the shop or to the offsite builder just wasn't important for the Revit model. So in some cases, it could slow down a model, for instance, to the point of being super cumbersome. I'm thinking specifically of instances of routing lines if you're cutting sheathing, glue lines if you're gluing that sheathing down to your panel. This type of information does not have any bearing on a Revit model. It simply does not belong there. But we've seen these things in Revit models so that we can output that data to the machinery. So we started to think of ways to pull this data away from Revit since it has no real value. At the same time, we're starting to see cloud services become relevant in our industry. So with the help of a few customers, what we did is start to bridge the gap between Revit and manufacturing output. And what we found that, while digging into this, a lot of companies were using Excel spreadsheets to manage things like roll orders, sequencing, and even stacking. And it's all influences how we build and the process of the manufacturing. So users wanted to have access to this 3D model. They didn't necessarily have the people that had the skills at the shop level to manipulate Revit. So we decided to build a platform for them where we can do all of this management and we can do all of this, this output from a model that is directly related to our Revit model and is as precise. So again, this is all database driven. So at the top screen, you see basically a good example of a structure that's being sequenced for manufacturing and for construction. Green panels have been sequenced, red panels are not yet sequenced in this particular example. And the sequencing, what does that do? It then flows into the stacking. Stacking of the panels for delivery on trucks is all managed from this cloud platform. So we're able to basically very easily do this workflow, all with Revit data essentially, in a cloud environment that is outside of the Revit environment. What's super important here to understand, if you're new to fabrication or roll forming, is that this is the step before fabrication. This decides in what order you're going to be manufacturing. So if you weren't able to do this previously, you were kind of struggling using Excel spreadsheets. Finally, one of the missing portions of this was the ability to edit data, specific manufacturing data at the CNC level. So on the right, we see the editing tool that we've created, again, cloud-based, so it's accessible by any browser. And what you're seeing are all these little spots and lines on the representation of the panel. And this is literally CNC code here. This is the 3D version of the CNC code. So you can imagine if you have a Revit project of maybe 1,000 wall panels, and you wanted to put in each one of those little dots and lines representing the code, it would become almost unusable. So we noticed that, we had to figure out a way to give the user the ability to change these CNC operations in 3D outside of the Revit model to keep things nice and light and flowing, while giving them the ability to basically check for errors. Because oftentimes, a Revit project may have an error which generates an error in CNC code, which if you aren't able to check it, or if you're only checking by looking at a CSV file, finding that error is going to be next to impossible. So that becomes wasted material. So here we have a good example of additional software applications that are allowing us to eliminate that waste. Preparing for this, I called a few customers to get some rough figures about how they feel this process has improved what they're doing day to day. So 20% faster design to production. So what does that mean, design to production? Well, that means using Revit as our single source of truth without ever having to leave the Revit environment for creating that framing model. Now, I'm not asking them to, I didn't ask them to give me the benefits that they see as far as collaboration and coordination is concerned. It's really just using the Revit model as a basis, framing within that Revit model, as opposed to other, software avenues where we had to frame outside of the Revit model and recreate the model before framing. 42% faster fabrication drawings. This is all about automating the software, the ability to create those 2D panel drawings, which are completely unsexy and not technological, but completely necessary in any fab shop. 10% productivity savings in project delivery. So this is really from managing the panel stacking, the roll orders, and the production sequencing in that 3D environment I showed you before, as opposed to doing it in Excel, and which was the case in most cases. And then really what's cool, 90% reduction of scrap panels. So I have to, there's a little caveat to that. This is really based on how many panels are being caught with errors before and how many panels were being caught with errors before. So now, excuse me. So speaking with the customers, they would see, on average, maybe about, 3% of panels had some error at some point, so they would have to scrap material and start again. These were uncaught panels, obviously. Now they've been able to reduce that 3% by 90%, because they have the ability in 3D to go into that panel and verify every single one of those conditions present in the project. So that pretty much wraps it up for me. If there are any questions.
On the workflow slide, you have step number 2 where you made reference to the structural model.
Yep.
Is there a change from, I know that this is the practical side of it. I know that when we're using your tool, we're actually using an architectural Revit template and not a structural template. Is it changing? Is it on the path to change? The reason I ask is I know that the only way we can integrate with robot and down the stream advanced steel is if we use the structural models.
Right.
So that's the question.
Yeah. So in general, the architectural model, and no offense to any architects here, is not a valid model for the purpose of fabrication. Amir is laughing at me right now, but for the purpose of fabrication, it just isn't. It's a basis. Okay, we're looking at it as a design intent almost, right? So what we're going to do is we're going to create a structural model around it for exactly this purpose, for the purpose of the fabrication model, but so that we can downstream these tools like robot and other things. I didn't talk much about it, but engineering analysis is a major part of what we do and what we hope to move towards, because there is a huge demand, not so much in North America, but in other places in the world where that engineering is not outsourced, it's done in-house. So we need to provide that to those customers. Thank you.
Our next speaker is Magdelena Kowalczyk. Magdelena is a research engineer with Autodesk Research Industry Futures and is based in London, UK. For most of her career, she has worked with customers to develop innovative solutions using cutting-edge design and manufacturing technologies. Her specialties include part performance optimization through generative design, additive manufacturing technologies, and design for manufacturing and assembly, with over a decade of experience working across different industries such as aerospace, automotive, industrial tooling, medical, and more. Currently, Magda's research focuses on the industrialization of construction, where she's been conducting research on the state of the industry, exploring technologies and trends, and identifying opportunities for innovation and growth within the sector. Her work seeks to apply a wealth of manufacturing expertise to the convergence of the manufacturing strategy and construction demands. In her free time, Magda enjoys watching documentaries and reading books, especially on naval history. Please welcome Magdelena Kowalczyk.
Thank you, Ali. Good morning. I'm Magda, so I work as a research engineer, and I'm here to tell you or introduce you to Autodesk research and what we do around industrialization of construction. So Autodesk is changing how the world is designed and made. At Autodesk Research, we advance this mission by exploring new possibilities where others might see roadblocks. We are a diverse team of scientists, engineers, industry experts, and we conduct industrial research to help our customers design and make a better world. So how do we approach innovation at Autodesk? Product teams are focusing on the needs of what our customers need now. And they work on 1 to 3 years timescale. At research, we're setting our sights farther into the future. We're looking 5 to 10 years into technology which might be still far from widespread adoption. And we're using this process called backcasting when we're trying to speculate the multiple features and then figure out the steps we need to take to actually meet the most desirable one. So this research, we have multiple groups. Science groups are developing this technology, the new technology, and engage with industry, with technical and academic communities through papers, patents, and prototypes. Industry future teams, so that's the one I'm part of, takes the technology from the labs and into the real world. And we're working with customers on applied projects, and these projects are never easy. There's always some workaround to be done, but the end goal is to produce a proper workflow for our customers. And then technology centers, they support external industry research, and we are in one of those downstairs. And our partners conducting their own experiments with their own set of problems are supported by Autodesk spaces, not just spaces, but also technology and software, and our experts as well. And what's important is they provide us insights into those emerging technologies and trends and signals. And this research engineering team, which develops that technology, they allow us to demonstrate easily the new techniques and the new innovations, so we can actually showcase this to customers and even our product teams. And the strategic foresight team, which they actually look more than 10 years. They look 10 years plus, trying to get this, foresee what the future might bring. The technology centers are the home to world-class fabrication capabilities and are an engine for connection and collaboration. They intended to bring a global innovation network to accelerate also our research goals, like the convergence of design and manufacturing. To accelerate your research, anyone can apply to become a resident of our outside network. On-site residents get batch access to one of the free technology centers where you get workspace to like office space, access to machine, technology, software, and experts, but also training and support of our great technology centers staff. We also have global residency programs, so this is the virtual network where you gain access to virtual community, virtual talks, events, but the opportunity of networking with other residents and Autodesk staff. So Autodesk is committed to supporting industrialization of construction and of course supporting our customers in this transition. And this is regardless if we are in product, customer success and consulting, or research. We offer a suite of products and platforms to support the many needs of IC applications, IC industries, from the design to manufacturing to production. Our customer success and consulting orgs are there to enable customers to get the most out of our products. So they're there to help you find the best way of using our products. And in research, we're exploring the frontier of new technologies and practices. In blue is industrialization of construction focus group from research. Now let's take a look at some of our projects. Many of you are, I think, are familiar with the project. The need for over 1,000 distributed healthcare clinics sparked a collaboration between Virginia Tech and Howick to redesign a clinics, especially for control of disease spread. So Howick's automated framing system was used to demonstrate that the primary structure can be produced and erected within 1 day as opposed to several months using traditional methods. The initial design was constructed in Entebbe, Uganda, using local materials, and similar system was utilized in constructing multiple mini hospitals in Zambia. And here you can actually see the design, the steel framing, and the external area it's a bit like this. Isolated wings around external outdoor area, which will have a triage and waiting area, so it will limit the cross infection between patients. The next project I would like to showcase is the robotic digital twin. Our researchers developed a tool set, which allows you to create virtual environment for the robot and a virtual copy of the robot. And then you take the VR controller and you can manipulate the end effector of the robot. Very complex movement of the robot arm will just simply be calculated based on the movement of the VR controller. So this process allows for very intuitive programming of robotic movements, which then prevents potential clashes with environment, but also with another robots if this is a factory setting, for example, when you've got multiple machines. The operator can control the robot by being next to it, but also can control in a remote location, so it can be another town, another country, apparently even another planet. Okay, and the last project to showcase is the DA Smart Bridge. And we work, DA is a civil engineering company, and we work together on this project exploring how the robot can build its own infrastructure without any human input. So the vision was to use decades of experience in building bridges and the data accumulated to supplement our own knowledge in manufacturing, of design and manufacturing, to feed generative design algorithm. And this, once built, the bridge would interact with its users and the environment to understand how it's being used, and then this knowledge would be then fed back to a software to inform the next generation of bridge design. And through this project, we worked with our Fusion 360 colleagues to advance the capabilities of our software. The bridge was designed using generative design to reduce weight, but also, most importantly, to make sure that it's actually manufacturable. So using all the manufacturing constraints. In this case, we had 3D printing, but there are other manufacturing constraints like for milling or die casting. So you can choose another method if you wish. And the second one, we have developed robot simulation natively within Fusion 360. And this allowed us to check the motion of our 7-axis robot over the 1 million points which make the toolpath. And the bridge was printed here in Boston, downstairs, which if you join us for the tour, you will see some artifacts from that build. Just to give you some statistic, it was 24 kilometers, which is 15 miles of toolpath, and the weight was roughly 960 kilograms. So these were the projects, and it's actually only a fraction of what is actually happening within research. So now I would like to draw your attention to a recent deep dive into the construction industry. And I'm sure most of you have heard this. By 2050, the predictions are there will be 10 billion people on our planet. So the AECO industry must create spaces for this growing population. from residential building to critical infrastructure, which is having a choice. We set out on a mission to explore how industrialization impacts the adoption and development of technology in construction. So what have we found? Firstly, there is a huge demand for civil infrastructure, and this drives adoption of innovative technologies. However, the industry is struggling to keep up due to social, economical, political, educational, and environmental challenges. Secondly, segregation makes it even harder to adopt IC technologies. We notice if the trade is sort of individualized, it's easier to adopt IC technologies. When more trades get on board, it gets harder and harder. Thirdly, variation in supply chain. It's not only availability of parts and materials, but the inconsistency between them. You can have the same material from different suppliers, and it's not going to be actually the same. Disconnected production workflow. So this is still a big challenge. And automation. So it has the potential to improve quantity, quality. However, the adoption, innovation is still, it varies, and it can vary across countries, regions. And finally, the rural presents a great opportunity to apply IoC technology and make a real difference for people working there and living there. So now to finish off, let me briefly tell you what my team and I are up to. So our vision is to ensure a digital continuity in workflows from design to make in IC applications. So you can see we are tackling the disconnected workflows from the previous slide. And the idea is to have those three engines which talk to each other, exchange data, and at the end, we getting design, which we know is not only going to be manufacturable, but we also know when and where it's going to be produced. Okay, so now to truly finish off, that is our call to action. Please engage further with our work. You can follow us on social media. You can go to our website. You can check our blog, check our latest publications. If you're interested in applying for outside network, application is there. You can find more information. But the most importantly, we are here in large numbers. Just come and talk to us. And let's design and make better worlds together. Thank you.
Wonderful job. Thank you so much, Magdelena. Quick question for you, Magdelena. The work that you all are doing is spanning industries. It's pulling together convergence moments where we're looking at these interlocks between multiple industries and how technology is being used. But I think some of the most fulfilling work that I've seen so far is also being done in partnership with customers. How would you agree with that?
That is the most important for us, and especially for Industry Future, which I've been part. Yep. Well, it used to be called differently. Now it's Industry Future. We've been always working with customers, and that was the most important bit and the most enjoyable one. Because that's when you really can get that understanding. Because like reading websites and stuff, like it's okay, and it's all what we do, but it's the customer who will give you the true drive to do your work.
Okay, so our next speaker is Amy Marks, Vice President of Enterprise Transformation Practice here at Autodesk. As Autodesk's VP of Enterprise Transformation Practice, Amy informs strategy on business outcomes, platform solutions, and consulting for customers, incorporating transformational methodologies, including industrialized construction, sustainability, and new ways of working. Prior to joining Autodesk, she defined the language, process, and frameworks that are adopted by many companies, universities, countries around the world, reflecting the convergence of the design, make, and operate models. Before joining Autodesk, Ms. Marks was the CEO of X-Site Modular and pioneered a path to become the world's preeminent prefabrication consultant, and is often called the Queen of Prefab, literally creating the role as the first prefabrication consultant. Ms. Marks champions the integration of transformational and innovative methods of working across many building types, including high-tech, healthcare, hospitality, data centers, residential, and commercial buildings. She has strong relationships across the world with many owners, architects, and engineers, and supply chain partners. She is a unique and outspoken agent for change that is well respected across many industries and is a highly sought after keynote speaker and chairperson of conferences on business transformation, prefabrication, and sustainability. She is a mom to her daughter Mackenzie and is also an avid sports fan, having played competitive rugby for almost 15 years. Please welcome my friend and the incomparable Amy Marks to the stage.
Man, you guys you're making me feel old today. Floppy disks and first ofs. First of all, I want to thank Howick for having me today. I really appreciate it. And we go back a long time to your dad's days. So I really appreciate the time, again, aging myself. Welcome everybody. I'm so excited that you're here at the Tech Center, because I think a lot of our customers don't understand the amazing opportunities that are available to you, from research to the Tech Center residency program, to participating in incubations and beta tests. It's the kind of thing that I talk about all the time. There are so many opportunities. There's more than one way in the house, as I like to say. I actually do have to show our a little bit of a debrief here, but this is our safe harbor statement. I'm also missing a few titles, but that's okay. Just give you a minute there, because I like to call myself a futurist, but I'm a near-term reality-based futurist. So I think that's a little bit different than being a futurist, because I always like to say I'm still wet and dirty from the industry as we talk about technology. So just to give you an idea about this word convergence that everybody's using, we're talking about the melding of things. Pressure creates even greater convergence. Think about it like a vice that's been on our ecosystem in our industry that creates, new processes, new technologies. But the part that I'm most interested is in new business models. How many of you can say that your business is different than it was 5 years ago? Raise your hand. So we just did a study actually at Advancing Prefabrication, and we asked a group of people, in the next 5 years, what do you think is going to happen to your business? And more than 1/3 of the people in the room said their business would be unrecognizable in the next 5 years. Unrecognizable. Now, almost 30% of the room were in the VP and C-suite executive seats. Unrecognizable. An even greater number of those people said that they would move further left in front of the design build process to inform and become more important in that process. I like to say I don't actually think it starts with design anymore. You're seeing a lot of loops around of like information informing the design. I like to think of it flipped upside down. But yes, we are leading the design make worlds here, hopefully with the make informing the design in these patterns that we keep seeing. I think that's really important. We have to really think about how this is going to change us. And you've heard some of these things. I want to, by the way, the one thing you didn't say in my very long bio, I apologize, is that my job is to make you feel very, very uncomfortable. Both Autodesk and our customers, right, Allie? Yeah, it's my job. I'm troublemaker number one, as Steve Blum likes to say about our agents for change. How many $14 trillion ecosystems on the planet do you know that have yet to be commercialized with e-commerce? How many? How many do you think are out there for guys like Amazon, Ariba, and Alibaba to get new ways of, bringing people into their platforms? How many $14 trillion ecosystems exist out there yet to be touched? We're pretty much it, right? And so all this cash for chaos that's been going on for many, many years is the reason people are getting paid on waste. They're not getting paid on value. And so you better think about when people say that their jobs are going to be very different in their businesses in the next few years, you have to think about things like expected experience, like what is going to happen, what's been happening around the world. One of the things I love about this slide, I love the fact that we look at by 2030, there's going to be 200 million construction jobs. I'm 51. I wish I was going to be one of those people by 2031. 41% are retiring. Look around you right now. How many of you are under 35 in the room? Raise your hand. 7 on average. We have a problem. Look around. How many people are in diverse populations? Allie knows I usually like to walk around and meet every woman that's in the room. That's getting a little harder. I'm pretty close to being able to do that. How many people look from diverse populations around the room? we kind of look a little bit of the same. I was on stage at a data center conference last week, a few weeks ago, 50 speakers, 4 women. We have an issue. So let's talk about pizza. How many of you, who's under one of those 7 people that was under 30 years old, how many of you ordered pizza from your Apple Watch ever before? Yeah, what's your name? Derek. Here's how Derek orders pizza from his Apple Watch. He can actually order pizza from Domino's on his Apple Watch. He can see when it's going, he can customize it, right? You can pay for it on some other app like Venmo or Cash App, whatever your preference is. He can see when it's going into the oven. He can actually understand the estimated time he has to run home from work to be wherever he's going to be to pick it up. He can ask for contactless payment if he wants to. He will know that that was a background check driver, know the license plate and make and model of the car. He will see when the pizza's on its way. He could actually say, don't ring my Ring doorbell, although he'll see the guy's face as he walks up so that his dog, you have a dog? I have a Labradoodle. Told you. So that his dog doesn't bark, so you can see him walk up so they can get his pizza. That is the expected experience of people that use technology in how you order a pizza every day. How many of you are over 45 in the room? Raise your hands. That's everybody else. So our expected experience, unlike ordering a pizza, is you're on a job site and you are calling somebody to call somebody else. Our biggest thing is we have cell phones now. To call somebody else who calls somebody else to see if your $400,000 piece of critical equipment is going to show up that day, while somebody who makes about $200,000 to put that piece of equipment in place and a crane that costs far, far more is sitting there unused while you wait for someone to call somebody back to see if you're actually going to be working that day. True? Not true. True, right? Raise your hand. Spirit, jazz fingers, if that's true. Yes, right? Like, why is that our expected experience? Why is that acceptable to all of you? Derek, start asking people at your job why that is their expected experience. Start asking them, you know you can order pizza with far more technology than what we're doing here today. And I think that's a really critical issue, is that our expected experience really has to change. And I would ask all of you this, knowing that your businesses are going to change, what does your business want to be when it grows up? I don't care in any country, in any language, whenever I say that in any translation, every CEO or COO can answer it immediately. I don't use a lot of fancy words. We don't have to say a lot of things. I say, what does your business want to be when it grows up? And they can all answer that. You have to start asking yourself, what is it exactly that you want to be? Describe it. Stop using these words, the business words that everybody else uses that I don't even know what the words mean anymore. I always say, I'll tell you a quick story. I know I don't have a ton of time today. My boyfriend never had Indian food, by the way. I cook Indian food at home. I have my own dosa batter, like grinder. I was like, let's talk about Indian food. So we went to an Indian restaurant. Everything was written down. And I said, I'm so excited you're going to have Indian food. And he said, what should I get? I'm like, what looks good to you? He said, these are all just words to me. And I was like, let me describe it to you. So I took out my phone and I started showing him pictures. And I realized that's not even enough. I had to be like, biryani's dry. It's very spicy. Like, spicy could burn your tongue if it's like a 10 out of 10. Like, butter chicken's a little bit milder. It's saucy. Like, I was like, you could put proteins in it. So now when I'm at work, I always say, describe it to me like Indian food. Like, what do you mean by that? And I tell them the story. I'm like, what does it taste like? How do I act? What does it walk like? What does it smell like? What does it do to me? How do I react? Like, what are the feelings about it? I think we have to start describing those expected experiences a little bit more like I described Indian food that day to my boyfriend. Because we use a lot of words. We shake our heads like as if we know what people are saying. And they mean, listen, design make, Gonzalo, I'm looking right at you. Design make means very different things to many different people. If you're in manufacturing, design make means something very different than you're in AEC, than you're in media and entertainment. We have to start describing what that design make experience looks like when we talk about our businesses. Change equals dissatisfaction the way things are now. How many of you are unhappy with the way your business operates? And by the way, that doesn't mean it's going awful. You could be aspirational that you're not quite where you want to be. How many people are unhappy? If you're not, probably not going to be growing much over the next 5 years. You're not one of those people that are changing. You're in the 1% that said no change whatsoever, 1%. So you have to have dissatisfaction. You have to have a vision for what is possible. I used to say an army of robot dogs are coming. If you got to spend a month with one of them, do you know how it eats, how it sleeps, how it plays, what it does in its free time? How many outlets do you need to charge it? How does it interact with your children? What is it doing? If an army of robot dogs is coming, like what do you actually need to know about it if that's the vision? After that, you have to have your first concrete steps of action. That is where we all fall down. You will walk out of this today and you'll be like, that was great. You'll go home and you'll have the same expected experience, some of you, that you had the day before. Pick 1 or 2 things you see today and create concrete steps of action. All of that has to be greater than resistance. Here is a trick. The resistance is not coming from external factors in your businesses. It's mostly 90% coming internally at your own company. Autodesk included, by the way. Internal resistance is what stops us from change. All of that if you don't have that formula, you cannot change. So we want to start thinking about how do we actually connect teams? Not just once, but across programmatically, teams that are working across the world with other teams. How do we make sure connected construction is connected processes and connected data so that we can use that data and not just have it go into the trash? My one friend who heads VDC at a big company said, we just did this almost $1 billion hospital. Let me show you all the cool stuff we did. And I said, great, how much of that is reusable? And he said, none of it. And I was like, then it's really wasteful. If that LOD 400, 500 detailed drawing is only going into the trash, and you can't reuse those components and understand metadata associated with each of those components and performance-based IoT sensor data, why did we spend the money to do this if it's not helping us? So connected construction and product development. So it's that product data from those jobs that you can actually configure and reuse. That's important, configure and reuse. Imagine a world like I do by the way, I order lots of stuff. I say I'm evidence-based. I order lots of things on my iPhone. I'm an Apple girl, by the way. I'm an Apple captivity. I love it. I'm a happy Apple girl. My car, my home, my phone, it all, platform. That's what platform really means. When you have that stickiness like I do with Apple, you know you have a platform. So how come when I order things on my Amazon app, I'm able to configure things? I see both distributors, manufacturers, and resellers. I don't just see one group. I can pick, I can configure, I can see research, I can see reviews, all those things, evidence-based. That's what happens with a platform. A guy said to me last year, my pipe spool will never be a commodity product. He was over 60, I'm not gonna lie. He was over 60, he was a plumber, and he said, it'll never happen, you'll never sell my pipe spools online. And I said, in 2019, Amazon had 145,000 private label products under 45 different private label brands. I put them in my mouth. I put them on my skin and in my hair. I put them in my baby's mouth and skin and hair. Your pipe spool is not so special, right? Your pipe spool is not so special. Imagine a world where exactly the way we buy things now, look, we have in-product chat now, we have things that can configure. There are ways in which you can buy things and connect and be in the cloud. We just haven't made it part of our own expected experience right now. And so look, I thought this was a very interesting thing from the Advancing Prefabrication Conference. We did a live research study, by the way. We taught little 5 to 6 minute vignettes about different topics, and then we asked people questions with their iPhones. So at the Advancing Prefab show, we asked, what could really enable you to productize the processes you do in construction into actual products? Because by the way, all the cool things we have in manufacturing work really great if you have a product. You can't have manufacturing unless you really have a product. Machines don't make infinite things. There are parameters. You have to have a product. It doesn't mean it can only be one product the way it is. You can have customizable, but it still needs to be a product. We said, what would actually help you? And 42% of this audience said a digitally connected marketplace. 42%. Even more interesting to me, I think people said, technology that would allow me to understand the variations I've made over time. If I've made 1,000 pump skids, why do I have to get Amy Marks, who's been working in the industry for so long, to sit down and be like, what's the best pump skid we can make if we try to make the top 3 pump skids? Why can't AI do that for me, Gonzalo? Why can't I take all the LOD 500 drawings I have, look across all of those and say, these are actually the 3 most, these are the most that created like the least amount of variable for you. These 3 pump skids cover 95% of everything you've ever made in the last 5,000 pump skids. You just make these 3. We all know that that's possible, right? But we don't do that. We try to wheel me out and my crutches will come out one day and I'll be like, let me tell you how prefab uses it. This is how you should do it. Like, we have guys in our shops that you can't live without. And you're not sitting them down to take what's in their domain expertise and applying it to technology. And you're not taking the technology you've used that's throwing things in the trash and figuring out what you should do next. I thought it was also interesting that 23%, almost a quarter of the room, said, if you could give me an easy way to capture it in technology, that would be great. They actually might know those things and they just don't know how or where it would go. My friend Billy Bullock at EAS is always like, if I made products, where would I sell them? But for my mouth and my feet. Where am I going to sell them? How many Revit buttons can search across multiple Revit buttons? You can have as many Revit buttons inside of Revit as you want, but you can't, this is my uncomfortable Autodesk moment. Once you make a Revit button, I still can't search across 70 Revit buttons and find the right combination of things out of those 70 different configurators that live someplace else in the cloud, right? We have to start thinking platform. We have to get across what we're trying to accomplish here. How do we define reusable components and pieces and parts? Design with those customizable pieces and parts so that we can make anything and make sure we have the metadata for manufacturing, and not just manufacturing, the operational carbon. How do we figure out the metadata of how it's made, what it does, the combination? We're in a highly automated, censored world. We should know all these things. And how do we then create information to inform digital twins to go back around and define those reusable pieces and parts? By the way, I can go on my Amazon account right now and find out how many times I bought brand X shoes and how they were ranked and how I like them and how long I've had them. But I can't do that for any component in construction at all, anywhere, just about, right? So you want to start thinking about solutions that we're working across in Autodesk, and a solution is not a software. A solution is a combination of softwares. Ours, other people's, Autodesk Platform Services apps, proprietary software from our customers. A solution is a big thing. It's got multiple workflows, and you need multiple solutions to get where you want to be when you grow up. One of them, this is called informed design, and one of those is also called common data environment. Those two things together in the future state will allow you to have pieces and parts with metadata so that you can actually know the combination. By the way, you can't have generative design without products. How many people in the room know computational design? Raise your hand. 7, again, 8, one in the back, just like kind of know it. We just can't do it with geometric spaces, with spaces anymore. And people know that I like to say dumb boxes. Dumb boxes aren't getting us there anymore. Why? Because that dumb box actually doesn't allow for me to make things in the most efficient way so that I don't have waste, right? That's why it's really important. We have to start thinking about how to make this scalable. By the way, my friend is also Jamie, and you guys, most of you guys are my friends that are in the audience. It's great when you can do something with 13 suppliers and you know the details. It's another thing when you have to go global, right? A lot of the cool examples that many people are showing are by using a small amount of supply chain partners that they are controlling the outcomes of these so-called platforms. When you can truly make it global and it's open, where you can combine both known and unknown information to create buildings, because right now we're at 3% known and 97% unknown. How do we shift that balance to have more known and less unknown, but still have them operating together so that we can continue down this path? It's not like you're gonna have products all in one day. We're not. We have to create and understand how this geometry that may still be empty works with things that are very fastener level detailed designed. And so we have to do it to make a more sustainable world. That is why I came to Autodesk. For most of you who know, I believe that we have the stack and the open platform to make that possible. I always say, if this is Autodesk, we always have to remember Waze lives on my Apple platform and they don't own it. Spotify lives on my Apple platform and they're still Apple Music. I don't like it. By the way, I went to Japan and Waze doesn't work in Japan. You have to use Google Maps. So I have the opportunity when I'm in Japan to even have a seamless experience when I have to switch the thing that I like to use. But think about next time how many apps it actually takes you to get from here to the restaurant you want to go to tonight. One day I counted it. It was 14 for me. Now, I don't know what Apple owns and didn't own of those 14. I never even think about those 14 apps. But you know what? I magically get to the restaurant. I know what I'm ordering. I know what I'm wearing. I know I'm there on time. I got a car out of it. I know my reservation got made. Magically. How do we start mapping out these things we need so this can be a magical experience? And I believe we're in the beginning phases of that with things like Forma and Fusion and Flow, which I believe, again, is the reason I'm here. And as proof of that, I'm always evidence-based. This is the Autodesk Construction Cloud third-party ecosystem. This is open. You can do a lot of things on the Autodesk Construction Cloud now with products that aren't ours. And some big announcements I can tell you. How many of you know what Building Connected is? Raise your hand. Ooh, by the way, kudos to this audience. I love Building Connected because I think it's a great opportunity. It's like the LinkedIn almost of construction. We just launched about a month and a half ago this new profile section in industrialized construction for both products, building types, and construction services. You can update your profile for free. Allison, we didn't do $1 of marketing. We have hundreds of people that have, companies that have already updated their profiles. This is the third conference it's come out of my mouth. Hundreds of companies have already updated their profiles, and you can find them there to bid them out. We have a lot of education. This master's level course that I worked on for free is there for you. There's a business course as well. So we also have the industrialized construction maturity assessment that you can do. And we have to work together because, as Dave said, digital waste exponentially leads to physical waste. So I've left a few. By the way, 1/6 of that waste in our landfills is drywall right now. 40% of what's in our landfills is waste. Could you imagine? By the way, everyone knows I love Yeti cups, Allison. I love cups. Anytime someone gives me a cup, I'm happy. If Yeti they got on the news and said Yeti has 40% of what makes their cups, it ends up in the trash, I'm not buying Yeti cups anymore. You should walk out of here and realize, why would we stand for 40% of what we're designing and making is going in the trash? So that's why we have to work together so that we can have a better world for more people in this planet. Allison.
Yes, thank you, Amy. So you're talking to, not unlike Dave, right? You're talking to manufacturers, you're talking to construction companies, fabricators, architects, designers, supply chain, even building products producers. What's one of the top challenges people are facing right now in terms of really adopting some of these transformative practices that you're talking about?
I think first you need to understand how you're organizing and sharing your information. So a common data environment at even its basic level is super important. And then I would say people are struggling with how to create product and process development in the construction space. So we have to learn from our friends in manufacturing who have done product development and process development and apply that to the AEC space to open up the world of manufacturing to us. Yeah. Machines are fabulous, but you have to have products that can be produced on the machine. You need to know what it is that you make and what you want to make, to move forward.
Yeah, awesome.
We have one guy.
One question right here.
Product development versus project development is a very good point, right? I mean, software world where I come from, it's all product development, right? And you look at the cash flow, it's all project development. When we've talked to some of the large AEC firms, I mean, they're wedded to the cash flow, they're wedded to the labor pool,
yes.
Right? How are they going to change that?
The answer to every question in life, in business, is money. Just, if you don't know the answer, first start with the word money. If you have the money and you're a serial owner these days, if you're Meta, if you're Google, if you're Amazon, if you're HCA, if you have 100 data centers to build, 25 hospitals, 30 manufacturing facilities to build, you get to dictate how quickly this ecosystem is going to change. That's top down, not bottom up, Clayton Christensen. It's the innovator's deception. You can't fix this bottom up. That's why I came to Autodesk. I was too small. That's why they got me, hooked me, to make the biggest change. You need the guys with the money, the government, people that are buying things, biggest owners in the world, to require this, and it's happening now already. You look at these data centers, they're 45 to 75% productized. They're not bidding out that work anymore. They have partners, sole source partners, that are making component parts for them now. And you have to change. The guys with the money, stop paying on waste. Start paying on value. That's the answer.
So our next speaker is Scott Mitchell, founder and CEO of Stud.io. Scott Mitchell is founder and CEO of Stud.io, a computational construction company. Scott works to bridge Stud.io's software development with its project consulting, enabling some of the most complex projects being built today. Before founding Stud.io, Scott worked as a software engineer at Autodesk as part of the AEC Generative Design Group. While working at Autodesk, Scott had access to a Howick roll-forming machine, which he experimented with in his free time before ultimately leaving to focus on the development of Stud.io full-time. Scott studies and practices film, music, architecture, and computer science. In other words, making things. He enjoys composing for the guitar, producing videos and animations, and experimenting with software development and prefab and fabrication research. Scott teaches at the Sam Fox School of Design and Visual Arts at Washington University in St. Louis. For the past several years, Scott and his wife, Brenna, their son James, and their golden retriever, Lou, have lived a modern nomadic lifestyle, living in various cities across the U.S., including Boston, Massachusetts, Laguna Beach, California, Austin, Texas, and Tulsa, Oklahoma, where Scott was born and raised. Scott and his family currently live in Laguna Beach and are expecting a new member of the family this fall. Please welcome Scott Mitchell.
I'm Scott Mitchell, founder and CEO at Stud.io, and I'm very excited to present Hacking the Howick Part 2. And you might be wondering, where was Part 1? Actually, 6 years ago, right here. I was an intern at Autodesk. And at the end of my internship, I gave a presentation called Hacking the Howick, basically covering the research I had done as an intern. That's intern Scott right there. And I spent the entire summer just exploring this idea that it seemed like you could do more with the Howick machine than people were using it for. Like, people build walls and trusses and things that are flat, but it seems like you could do more in like dynamic 3D complex geometry with this machine. So over the last 6 years, I think we've proven a lot of the ideas that were generated that summer. So this is part 2. I'm going to give you guys the update over the last 6 years. And one of the biggest changes is it's not just intern Scott anymore. We have a growing team of very talented designers and developers at Stoddart who are helping to push this technology and get it out into the industry and change the way that the buildings are being built. And we also have creative users of our software who are doing some really exciting things. This is a group of my students at Washington University in St. Louis who we gave the software to. And they all designed their own parametric, complex steel stud systems and then fabricated at full scale a version of their system with a Howick machine, which was a very, very great and exciting experience for both them and for us to kind of see how people were thinking creatively with our software. And of course, we have industry partners who are using our software on some very exciting projects that we'll get into here in a bit. But the message that I really am hoping to leave you all with today is that you can do more with your machines than you think is possible. There may be some line that you think is like, there's nothing past that that's really feasible for me to do with the machines that I already have. And we think that's totally untrue. The boundary of what's feasible is a lot further than that. And you don't have to make any major investment to get there. You might just need more intelligent software to enable that and to unlock that potential for you. With that in mind, let's dive into Hacking the Howick Part 2. And the reason that we feel this is important for you to extend what is possible for you with your machine is that more and more architects are able to and have good reason to leverage geometry to not just build boxes, right? Complex geometry can enable some really important things like sustainability, energy performance, optimization of materials and space, all kinds of good reasons to not just build boxes and to start designing and building more dynamic buildings. And we believe that you can do that with the machines that you already have. If you're unfamiliar with Stoddart, we develop automated design to fabrication software for machines like the Howick machine. And our Stud Finder software is the most versatile software in the world for developing designs for the Howick machine. It's built at its core with an understanding of the constraints of the machine and how you can connect members that come out of that. So anything that you can imagine within the realm of what's physically possible with the machine, you can design and build at scale with our Stud Finder software. So it's extremely versatile in that regard, automates the design architectural model to fabrication process as well as the assembly and installation of these things. And it's also versatile in that it's platform agnostic. We're not tied to any particular platform. We want to be where you are, where you're currently comfortable with. At the moment, we have integrations in Grasshopper and Rhino. We also have a dedicated web app. We have Revit supports through Rhino Inside, and we're looking at direct integration into Revit and Inventor over the next year or so. But the idea behind the software, you can give it any shape that you want, right? And it's going to allow you to automate the generation of a fabrication model, and then it will give you the fabrication information and assembly information to get that one-to-one. And we've seen examples of some really amazing, complex, expensive machines. This is using a cost-effective fabrication method that people are already familiar with to get incredible precision and complexity without a massive investment. So looking at steel studs in particular, we have a couple different connection types that are in the software. And there's certain constraints around those, but also parameters. So you can connect two studs back to back, for example. The software will automatically put a hole so that when you line those studs up, you just put a screw through those holes and it's going to fix them at any particular angle. But it's when you start to combine connection types that they start to do really interesting things. So with just those two connection types, what the Howick machine does very easily, you can start to do things that are extremely complex. Basically anything that you can imagine. you're going to see a lot of examples of complex structures, but the idea behind it is quite simple. We take the basic operations that the machine is capable of. The software includes and allows you to develop your own parametric connections that are meeting the constraints of the machine. And then you can deploy that as a versatile system across your project or across multiple projects. So this kind of like combining the operations of the machine in creative ways to make these connection details is at the core of the software. And this is one of my favorite because this Howick machine was meant to, it builds like straight studs. And we're segmenting and curving them, basically misusing the machine in some sense. Like it wasn't designed to make curved studs, it just happens to be possible given the operations that the machine is capable of doing anyways. If you have a Howick machine, you can make curved studs. It's not a feature you even have to pay for. It just exists. And Stud Finder, if you have something curved and you give that to Stud Finder, it'll just automatically put all those operations in the correct location to give you exactly the shape that you're trying to build. So that's the sort of concept behind the software. Develop your own details. I'm sure people have their own details. You might just be missing the tools that allow you to intelligently deploy that across your project. But a relatively simple concept here that allows you to do a whole lot of different stuff from a typical panel job. We're roughly two-dimensional here, but these projects have their own types of complexity, of course. But using basically the details that we just looked at. And people are pretty familiar with that process. But using the exact same tools, exact same machines, exact same ways of building, exact same details, you can start to do a little bit more with it. Like you probably didn't know that a Howick machine could build something like this. So using a software like Stud Finder gives you the confidence to sort of take on more scope than you may otherwise have been comfortable taking on. You can really get pretty much as crazy as you want with it. But in all of these cases, the idea is to preserve design intent using cost-effective machines and basically the same processes for all these types of projects. So I want to dive into a case study. This is the Fontainebleau Casino and Resort in Las Vegas. This is the entryway. It's the porte cochere sort of on the strip as you can drive into the hotel. And this is what it looked like about a month and a half, 2 months ago. I think it's pretty much finished at this point. But this whole thing is being driven by Stud Finder. So every single stud, every single connection, it's the connections that we just talked about. Every single screw hole, all that stuff is being driven by Stud Finder, fabrication and assembly and install of all these panels. So before we get into those details, just a little bit of information about the project. It is big. It's 500 feet from end to end, 100,000 square feet of finish, and 436 individual modules, each of them like 10 feet long, 6 or 7 feet tall, and all of them unique. So all of them a slightly different shape, if not a radically different shape. So let's dive into the modules a little bit. There are 98 knuckle modules, which are the more complex ones. That's where two or three or more of the beams are kind of intersecting each other. So you have to deal with the complexity that arises there. There are 16 legs, which are these large modules where it meets the ground. And there are 322 infill panels, which are the rest of them, which are the simplest ones relatively, but all of them, again, at least a slightly different shape from its neighbor. So let's look at those first. So as a builder, you look at that and you might want it to just be a box, right? Because that's easy to build. It's easy to put those frames together. But as an owner or a designer, you want it to be a little bit more dynamic. And if you take a traditional approach to this, where you just build each side and then try to put them together, you don't really have a good strategy for that. But Stud Finder is going to allow you to deploy the details that you need in order to get accuracy for free and automatically. So that segmented stud detail that we looked at, the handshake detail that we looked at, all of the faces of the modules connect together with pre-punched holes. So this gives you a system that adapts to whatever geometry you throw at it. Not just the sides of this get fabricated and built accurately, the entire 3D object comes together in a way that's basically foolproof, regardless of the geometry. No need for a tape measure, no need for a jig, no need for a protractor, nothing like that. And we don't stop at fabrication. So Stud Finder allows you to automate the assembly information, in this case drawings, for your projects. So this is a subsample of some of the drawings from Fontainebleau. You can see we're basically adding everything we can into the software to make it feel like it felt like putting a set of Legos together, including color coding the drawings with the frames that are heading out to site. These get put together in the shop. They show up on site, grab the red and the blue panel, put them together, find the holes that align, that are already punched on there. It gets built around the structural steel that was already on site, and it's exactly like the digital model, exactly like the architect's model. So in the background there, you can see that's where the knuckle modules are. That's where you have one beam meeting another. So these are the more complex modules, and they work relatively similarly, but there's obviously some additional complexity where the different segments are intersecting. But StudFinder automates that. So you just set up the system, throw whatever geometry you need to at it, and it's going to automate the fabrication and assembly logic for the module. So it doesn't matter if your information is changing across the project. You have each one is an assembly that breaks up into pieces, that breaks up into frames. And as the geometry changes across the project, or let's say the geometry happened to change halfway through the project, the system just adapts to that, and your whole process is automated. So here's kind of the proof in the pudding. This actually happened. They actually put these things together this way. It starts the relatively standard way of putting steel studs together, building them flat on the table. Then you starts to get exciting as you put them together in 3D. The one thing that's interesting, it's hard to measure efficiency because it's not like someone's building the same casino next door as a control to compare ourselves to. But we can compare ourselves to client expectations. And in this project in particular, the budgeted assembly time that for these complex modules, we ended up taking 1/3 of that. So obviously a huge value for cost and schedule. And then also it looks pretty sweet, these knuckle modules. So I think these are some of the coolest looking things we've put together. But we don't just stop with steel studs and roll forming machines. So the same idea we can apply to other types of fabrication. The steel tubes is another one that we're using pretty frequently. So it's, okay, let's add that to StudFinder. But the idea is the same. You're developing these connections that doesn't matter what geometry you throw at it. The machine's going to make it the same way, and people just put it together basically in a foolproof manner. So in this case, you have teeth that are laser cut into the tubes, and then those register into holes that are laser cut into plates. And so the machine takes care of your complexity, the software's managing the complexity, and the human just has to put the Legos together, essentially. Another machine that we've done some very exciting projects with is a rebar bending machine. It's kind of like the Howick machine, and it just takes in a coiled material and mass produces a whole bunch of precise custom parts. So this was used on a project in Denver called One River North. It's a ridiculous project. The architect carved this big canyon into the facade. So we want to build this with StudFinder and with the bar bending machine. And underneath this plaster finish is all of these digitally fabricated rebar. All of them obviously a slightly different shape or vastly different shape. And they're prefabricated off-site as a set of pieces that just kind of click right into each other to come in to create the full geometry of the architectural model. And this is a super complex project, but that complexity is all managed for you. Right? The software handles the design of the fabrication and assembly information, and then the machines are handling the accurate production of that. So you just need to kind of set up, here's where I'd like my panel to be, here's what I think the spacing should be, and you can just send that out to all the files you need to make those parts at any time. So any change, okay, let's adjust that, let's move that a couple feet across, not a big deal, just re-export the files and they're updated to your current model. And again, so we have fabrication information, assembly information is just as important. The drawings are fully automated and just basically you export your current model as assembly information for the people putting it together. And again, the whole point of this is to use machines that are meant to make standardized parts, but we can make custom parts with them. That means they're cost effective. They cost basically the same thing as the standard parts. And we can preserve design intent without some crazy investment in the hardware to build this stuff. This is another very cool project that's nearing completion right now. I think we've come a long way in 6 years since intern Scott was here exploring these ideas. I think we've proven that, especially with the Howick machine, there's a whole lot more you can do than you might think. So we're extremely excited for the next 6 years. Look forward to part 3 eventually. And whether or not you're using our software or not, I hope this has kind of inspired people to think about how you can do more with the machines that you already have. So thank you very much.
Any questions for Scott?
Thank you. Very impressive software. As far as, is there an engineering platform side of it, or are you just working more from the third-party engineers?
Yes, so our software itself does not handle that right now, but we work in platforms, and basically every project we're doing, we're kind of cycling that through an automated engineering process at the same time. So you need to work in conjunction with something else.
And then a second question is, are you selling the software, or is your team doing all the modeling and detailing side of it? Are you selling it and then training? We would have to worry about training our own team to do it.
Yeah, so we are part of the way through that transition from the consulting to the software licensing side of things. We already have people licensing the software, so we've made the jump. We haven't quite scaled that yet, but that's a huge thing that we're going to be working on over the next couple years. Training is obviously super important to that. So what we've found is like consulting can sort of open people's eyes to what's possible with their machines. Then you give them the software and train them with it, and eventually you can step back.
Sounds great. Congratulations. Thank you.
Yeah,
Thanks.
awesome. I think you have some potential customers in here in the room.
Yeah, that's great.
Exciting. Another question? Oh, go ahead. Yeah.
Since I took the mic from him, are you finding that you're usually getting involved on the GC side or the design team side, or both?
So we are, for the most part, from the contractor side. But the earlier we're involved, the earlier people understand how this thing's actually going to get made, and the less likely they're going to run into trouble. So we've started working directly with architects who are putting, usually in the design development phase. So mostly contractors, but more and more so working with designers.
So our next speaker is Raafat, Chief Innovation Officer of Windover Construction. Technology leader and expert in the construction industry's most cutting-edge technologies to streamline project procurement. With more than 20 years of experience combining architectural, construction, and engineering expertise, Amr has more than 20 years of experience combining all of these amazing disciplines. In recognition of his pioneering work in construction technologies, Amr also recently received the Global 2019 Innovator of the Year Award at the Autodesk AEC Excellence Awards. Amr leads Windover's VDC team and the Innovations for Design, Engineering, and Automation, the IDEA platform initiative providing 4D planning, MEP BIM coordination, laser scanning, drone mapping, virtual and mixed reality, prefabrication, robotics, additive manufacturing, and automation to enhance planning, scheduling, site logistics, and safety throughout all construction phases of Windover's projects. I think you got a big job, Amr. Amr received his master's degrees in architecture from the Boston Architectural College. And a fun fact about Amr is that he has earned his black belt in karate when he was 16 years old. In his free time, Amr enjoys traveling to historic places with his family, and he currently lives with his wife and 2 young daughters in Lexington, Massachusetts. Please welcome Amr Raafat.
Hello, everyone. Excited to be with you today in this building, the Tech Center. We've been here residents for 5 years, actually more, a little bit more. And here I consider it a hub for innovation. Here we have built collaborations and partnerships and friendship with so many innovators from different industries, from manufacturing, folks that we wouldn't be working with, from Australia, from New Zealand. And I'd like to give a shout out to the Howick team, who is really bringing all these great folks together, pushing innovation every day on the work they do. So I'd like to introduce a little bit about Windover Construction. We based in Boston. We build everything from schools, academic, life science, commercial, multifamily, residential, and we are really the go-to in New England for modular construction. We have built over the years this great expertise in-house with superintendents, project managers, and technology team that can push innovation and make sure there are certainty of outcome for modular construction. We have launched 3 years ago the IDEA platform, which stands for Innovations for Design, Engineering, and Automation. we wanted to extend our technology and leading edge services to a broader spectrum of folks in the industry. We work with architects, peer group, construction companies, and manufacturing around the globe right now. We worked with Emaar, one of the biggest developers in Dubai. We worked with Hickory in Melbourne, Australia, and around the US with laser scanning, drone surveys, BIM coordination. And we thought that's our platform to help push and provide and extend our services to everyone. I'm going to go through real-life examples of how we are pushing innovation throughout the life cycle of our projects. These are real examples with schedules, tight schedules, and budgets, and how we are utilizing innovative solutions along the way to build more efficient. This is a project in Somerville, which is about 30 minutes from here. This is what you're seeing here is a standard for our work. When we start any project, whether it's modular or traditional construction, we start with a 4D sequence. We do it in 3D Max. So what we do is that you have linked with the schedule key milestones. What this helps us is understand the site constraints. When we bring those trucks with these modules, how we're going to fit them, safety planning, logistics planning, identifying discrepancies and clashes with existing utilities. So that's the best practices when we bring these off-site elements, how we're going to fit them on site, in addition to syncing to schedule, to set expectations between not only our trade partners on site, but also the client and the city. This is a great tool to communicate with the city. What you see here is a drone mapped scan, by the way, of the site, and not a model. Now into that collaboration with between Autodesk, Howick, StrucSoft. What we did is that we had this 120-year-old building, which we figured that the ceilings for that building, a really old building, is not even. So what we actually did is that we came up with an innovative solution together. This is StrucSoft. What we did is that we laser scanned the building, figured it out, worked on the Onyx, and what you will see here, what the power of the telescopic technology is that it can actually fit within, it can travel very small, like small Lego pieces, and when it goes to its intended location in a building, very tight elevators, very tight corridors, it can maneuver through the spaces. So when it goes to its intended location, it can expand and fit with any spaces. What I call that adaptive industrialized construction. It can adapt with any geometry, and that cut a huge time saving on site without having to adapt and cut on site. It really increased safety on the job site as well. The power of this technology really is how it can adapt with our existing. It can work for our life science projects. You can fit out spaces very quickly, isolate areas. It can work with any fit out that we wanted to do with increased efficiencies. As you see here, we did it at the Autodesk Technology Center. That was our factory. A really amazing team, and we assembled these pieces. And when it travels to the site, it goes and expands. As you see here, it goes very small. We're actually working on a project similar right now. You see it goes maneuver within tight corridors, goes to really small elevators. It can really apply to any existing condition site. And when it goes to its intended location, it expands. This is very powerful for our field team. Really loved this because it's really making their job safer and much faster. And what I really like about this technology overall is that it's very green. There is no much waste in the material you produce when you use the Howick machines. This project also had a challenge. We had to rip off most of the inside and add new steel elements. So how we make sure those steel beams that's being made miles away will come and fit perfectly within that existing structure to remain. What we did actually is that we laser, you see that point cloud in Autodesk Prefab and in Revit, we laser scanned the existing structure to remain, the facades, and we did QA/QC overlays with the beams for the steel to make sure that when those steel beams will come, will fit perfectly within the structure to remain. Another project we worked on here is at Tufts University. This is modular. What we did is that getting involved early on the project, we've been helping them test fit how these modules will fit on site. As you see here, it's all the studies. We scanned the existing utilities on site to make sure that we can coordinate it very well in a very short time to deliver that project and towards certainty of outcome. So this early modeling and test fits is really important when we start working with the factories that's making the modules to set expectations and working along with the design team, of course. This project needed almost 1,000 trusses, 935 trusses for the roof. What we actually did is that we collaborated with Autodesk and with Stoddart. We actually were able to create almost 1,000 trusses in 15 hours only using the Howick machine. So much efficiencies out there. And then for years, we've been using mixed reality to view how buildings will look like in the future. But for this one, we collaborated with Hologram in Australia, and you see how these collaborations being built in here at the Tech Center. Worked with them, utilized their leading edge mixed reality solution using the HoloLens. So you can, guys, it's like assembling IKEA furniture without having to look outside of the task in hand. It increased efficiencies, so they don't have to look outside. With that, we were able to increase efficiencies in assembling it, and it also brought so much fun on the job site. When our field team, we empower them with these technologies, it really enhances safety, efficiencies, and bring the fun to the site. We actually used additive manufacturing here at Autodesk. This is a historic 120-year-old building north of Boston. The facade was originally done in plaster. It was falling apart, and the client asked us to renovate the building and renovate the facade with the most efficient budget we can and the highest quality you can. So what we did is that we laser scanned the facade, and we created a detailed Autodesk Fusion model of that to the millimeter accuracy, because you carry over versus the traditional methods. You carry over all the laser scan data, and it carries over in the model to create exact replicas of these pieces. We're able to 3D print some of these elements using the 3D printer here at Autodesk, using additive manufacturing, and it uses a recycled material that would stand for another century with no maintenance needed. As you see here, it's also lightweight, very accurate. This is exact replica of how this facade looked 100 years ago, and everything above this column line was digitally prefab using a 5-axis router, beautiful small rosettes that was done by hand 100 years ago. We're able to create the exact replicas of them using digital prefab. So that's another way of how we can tackle the challenges of shortage in labor, skilled labor. We don't unfortunately have the folks who can really do this by hand, and even if we do, it's not going to be very cost effective. It's going to take a long time. With that, in hours, we can create exact replicas of that, again, using laser scan reality capture combined with additive manufacturing. This is another project of how we can provide certainty of outcome for project. This project won the EEC Excellence Award in 2019 for transforming how we coordinate modular construction on the job site. It's in Beverly, Mass. It's architected SV design. And what we did actually is that this is another 4D that's best practices for us, help us plan projects early on in the process with the key milestones, help with the city. The challenge on that job was that it has a podium of steel in the first 2 floors. This is how it's built. The scale of this is huge. You have 2 buildings, building A and building B. And the challenge for that job is that you have a steel structure at the podium and the modular construction above. As a challenge of any off-site construction projects, you want to make sure that these off-site constructed elements or boxes will fit perfectly above, the vertical shafts will fit perfectly above the as-built components. So we want to make sure we coordinate between as-built steel, not only drawing steel. So after the erection of each steel phase, we laser scanned those steel, and we did QA/QC overlays in real time, and we communicated in real time again with the factory in Canada who is prefabbing those boxes, and we tell them, hey, your vertical shaft for MEB will hit steel by these 2 inches. Can you edit them here? And then we were able to make sure when those boxes arrive, all these vertical shafts with MEB will fit perfectly on site. That's certainty of outcome using laser scanning. This is another way we use the Autodesk software innovatively. This is Autodesk Civil 3D. For years, been used on a flat surface when we drone a site or capture with a survey a site you created on a topo. What we did is that we flipped it as a facade. We're able to detect the blumminess of that facade using the laser scan data so we can communicate again in real time to the facade folks how this facade is behaving after we placed all these boxes, so they make sure when they put the facade elements, we preserve the design intent and make sure everything will be smooth. This is a finished beautiful project in Beverly, Mass. This is a project at Dartmouth College. This beautiful terracotta is coming from Spain. The glass was coming from Germany. It's actually built upon a structure to remain that is actually a 1970 building, I think. What we did is that after we stripped off all the details of that building, we actually laser scanned the whole structure to remain and did QA/QC with overlay with the design drawings and communicated, hey, that building 30-year-old, that structure 30-year-old is not a perfect square. Then communicating these a little bit discrepancies with the design teams, you're able to adjust the drawing so we make sure when these facade elements arrive on site and being fabricated off-site, when they come there, it's going to fit perfectly on the existing structure to remain. The constant communication and QA/QC using laser scanning reality capture with BAM is really key here. This is another example. We collaborated with Autodesk Takeoff, great friends of ours, in using models from design drawings to expedite the quantity takeoff process. Details, virtual mockups is very important early on to make sure how these preset pieces will put together on the field. It helps communicate with our trade partners on site. This is QA/QC overlay. It became, whether it's a modular construction job or a traditional methods job, building it with any other method, it became a standard for us to do this. After we put QA/QC overlays, after we put all the underground pipes, we laser scan, whether it was a LiDAR drone with ground control points or a laser scanner on the ground, we laser scan those pipes, vertical risers, and they do QA/QC overlays to make sure every pipe on the underground will meet its intended location on the first floor. Imagine that's before we pour concrete, because once you pour concrete, it's really hard to break onto these, cause delays. So that's the whole purpose of our work as a technology, tech-first solutions, is really to make sure no surprises on the job site. That's the whole purpose. This is a beautiful building that came out in 8 hours on site. There is a time lapse into it. It was assembled on site with modular construction in only 8 hours. One of them, there was a nice time lapse for it. This was during COVID, and all these trucks coming from Canada with boxes really needed to finish the job within a day or 2 days at most. So what we did is that actually to do certainty of outcome, after we put this slab, we had to confirm the flatness of this slab is that it is within ½ of an inch. How we do that? Again, laser scan of the site of that slab, and in Civil 3D get spot elevations and communicate that in real time to the field so they make any necessary adjustment to make sure of that. That's a twin build. We use it with our friends in Australia. It's got these codes, bring the accuracy to really good accuracy in there using those codes, and we use it for pre-assemble. Like you see that millwork when it's getting prefab outside. This is an innovation space that we built at the Belmont Hill School. As you see here, we wanted to communicate and overlay the 3D models for coordination purposes in the actual space to make sure everything will fit perfectly when it arrives there. And we use it for MEP systems as well. And finally, this is a collaboration that we're doing with Autodesk Tandem team. Windover right now is building with Blueprint will be the biggest mass timber projects in North America. It will be in Connecticut, and Windover is a CM. What we actually did is that we started from now, and we did it at PE as well, building that Autodesk Tandem model. What it is allowing us, after we finish many projects, or 90% of our projects, we end up with a fully coordinated Navisworks model. And then at the end, it sits on someone's computer. What we're doing is that we're empowering our client, who is not an expert in BAM, that they can use that years to come and use this data at their fingertips with their iPad, with their computer, to really monitor the building. We are adding IoT sensors at Phillips Exeter Academy. They have all the O&M manual data, so they can really support the future facility maintenance and management. This is information-rich data that at the fingertips of clients who don't really need to be experts in BIM. And it's really transforming our handover process, which for years been about books that no one wants to really read it, okay? So this is very easy to use, doesn't require any training from any user. We used it at Philips Exeter Academy. It's been a success story. They loved it at the facilities team there. And one more thing, we're collaborating with Stoddart, the LAD team, Howick, Autodesk, and Hologram, our friends from Australia. They wish they were here. This is really about exploring new ways and redefining what we can do with light steel gauge, taking a new, fresh ideas and try to apply it with different technologies, as you see here, using Hologram to assemble it, using amazing Stud.io, StatFinder software that's compatible with all our softwares we use every day. It's really redefining what is possible. The most important thing that we really need to focus on is using technology to really offer solution for the challenges we have every day on job sites, and it's a collaborative effort between a superintendent on the site, project management, technology group, folks, great folks like Autodesk pushing the industry, and manufacturers like Howick. All together, we can really advance our industry together through these collaborations. Thank you so much.
Fantastic, Amr. Any quick questions for Amr?
The question is, how much does the scanning impact the production facility? Meaning, the premises in the offsite, things that start way ahead before the on-site itself. So if you're scanning and there's a module being built or multiple modules and a shaft changed 1.5 inches, how is that synergy going on?
You're bringing up a great point. That's why you found me saying real time all the time. Because in the Canvas example, while they're making the boxes in Canada, with our partner there, building the boxes, we communicate this information in the same day. The power of the laser scans, you can, in Autodesk Recap, process all this data in like half an hour or an hour, do all these QAC overlays, and have a quick Teams call with the factory and tell them, hey, that's what we found on the steel on the site. So the key is real-time communication. If you give them this data 2 days later, not good. They not really use it. So the power that's empowering us really now, laser scanning technology really advanced with LiDAR drones, is that you can process data very quickly and communicate that very quickly to the factory in real time so they can make the adjustments according to the findings.
As the construction manager, do you have some kind of a buffer on your schedule to account for those things? Because I know all it's going to come down to liabilities and delays and all kind. You know, I'm the fabricator in that supply chain, right? Yeah. So who's the one to blame, right? If things goes wrong.
Oh no.
So right now, first of all, the laser scanners we use Faro laser scanners, get calibrated all the time. It's you have to trust. It's one of the best scanners that we use. Its accuracy is within 1 to 3 millimeter. That's what we use. Also, we process it in Recap. But here is the thing. Right now, we see it a collaborative effort. It's not like you or me. We all assisting each other to finding discrepancies early, so we do the best we can to avoid any surprises or delays on the job site. So as I said, it's all about, you're bringing up a great point, Dave. It's all about combining different technologies. You have reality capture, which include drones and laser scanning. You have the BIM, which you do with the QA/QC overlays. You have the prefab factory who really know how to fix these things on their end. And you have the design team who is really forward thinking and providing these design models to us. So it's really accessible when all these partners work together in an open, transparent environment, a really collaborative environment, so we can really make this work.
I'd like to introduce our next speaker. Jim Stoddart is a research scientist in the AEC Industry Futures Group within Autodesk Research and a core member of The Living, an Autodesk studio. His work explores how new design, construction, and material technologies will lead to a better built environment for our planet and its inhabitants. Jim has collaborated with a wide range of industry leaders to demonstrate the value of new design technologies, including biomaterials, machine learning, and generative design on real-world applications and built projects. Jim has authored several peer-reviewed papers, holds patents for key generative design applications, and contributes articles to industry publications. His design projects have been widely published, won multiple industry design and innovation awards, and have been exhibited at international venues. Jim lives in Atlanta, Georgia with his wife and 2 kids. In his free time, he likes reading books and comics and cooking and learning new crafts. Please welcome Jim Stoddart.
Thank you. Yeah, it's a great audience to be here, a great group to be talking with. Just as a kind of precursor to say that my background is in architecture, so I'll apologize. I'm trying to unlearn some of the things about design being first. And some of this journey we're going to talk about today is this transition from how to make, to kind of get to that vision that Amy was talking about, that design is actually being driven by how you can actually build things. So before I go, I also have a safe harbor statement just to note that everything I'm talking about today is a research concept or research prototype. So none of this is in any current or future product roadmap. So don't make any purchase decisions or call your stockbroker based on what I'm showing today. But the hope is that we're trying to prove things out that really shape the next stage of technology. So as Magda mentioned, I'm part of this group called Industry Futures. I'm on the AEC side of this, and really Industry Futures sits in this interesting place between core research, which is developing the kind of basic technology that's going to power kind of new workflows. So these are new algorithms, it's AI workflows, it's interactions with software. And then there's industry. So it's all the people out here who are doing really great things, kind of pushing the envelope. And so Industry Futures kind of sits in the middle there. We take the technology that has been developed in research and actually try to test it and validate it in the real world. So we find willing partners. And what we do is we try to demonstrate on a real world project. And the advantage there is that, in testing things, when you get it out of the lab, you start to understand the frictions and the opportunities. So there are things that don't work when we actually try to do it on a real project, but also there are little hints we get about things that might start to change the way we are going to work in the future. So our team has a deep history of actually doing this sort of experimentation through buildings. On the left, you see a project with this novel biomaterials. This is bricks grown from mushrooms. We built this 40-foot tall tower that was composted at the end of the project. On the right is this open source building we did for Princeton, where we had to rethink the way that we started to detail and to document the building, because the goal was that this became an armature for research for the students, the researchers, the faculty, to be able to take the building apart and replace components with their own prototypical parts. Ultimately, the history of buildings is really defined by technology, right? New materials, new techniques, new technology is evolving how we design, but also defines the limits of what we can build. And so that's really, what our team is doing is we're building these prototypes that test that limit of possibility, so that customers can hopefully, if they work, be able to take those and integrate them into their own practices and their own projects and their own building products, and kind of deliver innovation for themselves. So a key area that my team has been looking at is this topic called generative design, specifically generative design for AEC. Fundamentally, generative is a combination of parametric modeling, performance simulation of evolutionary algorithms. And what it lets us do is it lets us explore really complex problems using the powers of automation. It works because it is this collaboration between machines and humans. The human provides the definition of a problem. That's something we're really good at. We provide hints at how we should start to solve the problem, but the computer really lets us do things like rapidly explore options and start to correlate huge amounts of data. In the mid-2010s, we'd seen a lot of examples of this for manufacturing, but kind of demonstrations in AEC were a little bit scarce. So we kind of ate our own dog food, and we did it on the Toronto office. Apologies, this is a 8-year-old video. You might have seen it before. But really, this kind of covers the kind of basics of it. How to start understanding the constraints of the project. How do you start to evaluate what is good and bad in terms of design? How do you start to do things with kind of messier things like people's preferences? And then how that all fits together in this loop where we have a system that can generate new designs, systems that can evaluate those designs, and systems that could start to evolve better versions of those designs. From a design perspective, this is a space planning problem, so it involves creating some sort of geometric representation to tell the system, how it can make new designs, things are get fixed. There's areas that the system can manipulate through, variables and inputs, and a typical parametric model. But again, the idea is that we're defining the range of possibility we want a system to explore, and that the types of things we want to create, procedural logic adds all the rest of the things, amenity space is the desks, and this thing is scrubbing through, but essentially it's able to create a kind of continuous space of design. I would say 90% of this is crap, you wouldn't actually want to build that, but the idea is that the system's able to then test this through these evaluations and start to find the gems inside of this. So there's systems to figure out how close people are to what they need to work with, or the people they need to work with. It's checking to see are people placed somewhere that's going to be compatible with their work style, what are the activity levels were in the office. Let's see what comes next. Productivity, so this is trying to measure the distractibility of people based on visual and kind of audio sources. Daylight, we're trying to maximize the use of natural daylight and minimize the use of artificial lighting. Views of the outside, this is offices in downtown Toronto, full of glass, great views, so we want to make sure everyone has a great spot. And then the system is essentially churning through a lot of options. It's testing a lot of ideas, and then every generation finds the best version of these. It crossbreeds them and makes children. It does this over the course of generations. The idea is it's a loose kind of replication of what we understand as natural selection. And there's a lot of literature about stochastically it's able to find good solutions rather than kind of brute forcing the problem. The input, we always hear these things about thousands of designs. Again, I would say 990 of them are crap, but the idea is that it helps us find the gems out of that, and then pulls those designs out as kind of key candidates where we can make a decision. Is this meeting our design goals? Is it meeting our the key trade-offs we want for the performance of space? So just to say, jump ahead, we actually did this. We took the design as the basis. We architected the rest of it and kind of built a design set out of it and ended up building the space. The outcome of this was it's a great space. It's a nice office to work in. Everyone loved it. But ultimately, the kind of key thing here is that it really did prove that that the idea worked. That we could actually use the software that came from the manufacturing space to actually change the types of spaces that are coming out of the design system around kind of these complex questions of how do we create high-performing space that works for a diversity of needs. That's just space planning. So space planning is a hard problem already, but when we get to the point of construction, we're talking about increasing complexity. It's not just adding more details to our models, but we have to represent the relationships of how things are built with the things that are being represented in the model as designs. Framed from this is maybe a pedantic example, but typically in a typical design fashion, we kind of work from the top down. We always deal with the kind of constraints set by the people before us. So someone makes a decision about how the buildings are laid out on site. That decision then indicates something that has to be reacted to. And then finally we get to the point where we're about to construct something, we realize we've created this new condition that is throwing off our efficiency in construction. Maybe not with a Howick machine, but with wood studs, that's maybe a bit of a problem. So what we can do is we can either live with that, we can eat the cost, we can go back, and we can kind of start from scratch, try to solve the problem. But in reality, there's someone smart working at each of these steps, and each of these steps actually has a level of intelligence in why they made certain decisions. So there's no real black and white about any of the benefits or negatives of each of these. The colors are a little off. They should be red and green in terms of good and bad. But just to say, this is a complex situation. So we can always simplify problems. We can ignore impacts. But in reality, this is an opportunity for a generative system to actually be able to navigate the complexity of the problems that we want to kind of work through to kind of create better design. So part of this is actually starting to think about kind of problems as being multi-scale problems, not just one big model that does everything, but a series of interconnected problems that can start to talk to each other and can solve things all the way from all the scales of a project, because we know in order to do things meaningfully for sustainability, designers want to make more sustainable buildings, but if they don't know how things are built or they don't have control over that, they're never actually going to achieve that. Likewise, if construction wants to do sustainability but their hands are tied, what's happened from design? So really, we think there's this opportunity to connect everything from end to end. So we're working with a volumetric modular prefab company, and they do everything all the way from development. So they're designing sites, they're configuring the buildings on those sites, they're changing the modules based on some of the parameters there, and then all the way down to defining each of the panelized constructions making these things. Each of these steps has its own metrics, right? We could say what makes them good or bad. Each of these things could be their own generative optimization within self-contained, but really doing them separately would propagate the problems we already see with the kind of silo design and being locked in by earlier decisions. And we also know too that there's really connections here, right? Like I make a site layout in a certain way, all of a sudden I create an acoustic funnel. The side of this building's loud, so I have to change the construction of the wall to hit a better STC rating. And then that's hitting the cost of construction, and then that percolates back up. The project cost goes up. So again, if I don't have understanding from high-level design to low-level design, I can't actually make those sorts of I can't actually do anything about that. I'm kind of locked into a reality that I don't have any control over. And so what we're really thinking about is how do we start to set up a system where we actually kind of make those connections? How can the computational and generative workflows actually help solve those problems by having this holistic approach to design? And really, I mean, one option is like we could have a giant model, huge LOD, a lot of digital trash, which we don't want. And also, people are very good at working at the specific scales. We have design representations at each scale that makes sense because we need to work with detail. You don't need to see the fasteners when you're designing at the site level. But the way to do this is actually we can build a data layer underneath all these models. So we're thinking about, we have systems where we're building graphs essentially that represent all of the connectivities and relationships embedded in this model. So every element knows how it relates to the other elements, how it relates to the whole, and it kind of establishes this hierarchy without having to create, again, one giant model. The other thing we're thinking about here too is the process of making models that embed a lot of complexity, a lot of relationships, is that computational design still is a difficult problem, right? The more competent your system is, the more likely it is there's only one person in the office who knows how to use it. And so that's a kind of a key focus area for us is like how do we make that process simpler because, again, all of the companies working in IC have products that have a lot of embedded design intelligence and construction intelligence in them. So how do we work with what we already know and what's already built into the models without having to build extremely complex node graphs? So we've been working on a prototype, again, this modular company where all the inputs are just their unit catalog, and all they have to do is provide some examples in terms of designs of how things fit together. They don't have to do any rules or anything like that. And then the system's able to go through and actually digest this. It's going through and scanning and finding out all the right relationships, all these constraints, extracting them out, and then it's able to generalize this back and create new buildings from this. So you're seeing kind of like a wild array of these things, but the idea is, again, combinatorial design is something that's notoriously hard to put in a parametric model, but now they have a way to kind of simply define the types of buildings that you make, and then within their generative model, as it's laying out a site, multiple buildings, it's able to go through and kind of produce these things with consistency and kind of obeying all of the rules that are embedded in their design system. That same model also connects to additional prototypes we've developed in research. So this is a structural optimization solver. This is essentially optimizing the design of the structure from the geometry before based on gravity loads, wind loads, seismic, shear forces, and it's trying to optimize to reduce the weight, reduce the embodied carbon, reduce the cost, all while maintaining structural targets. So here you see it's going to search for the ideal shear wall location. And it works also with a lot of different structural systems. So this right now is just for stick framing, but it also does post and beam, concrete, steel, mass timber, et cetera. And yeah, it's searching for ideal shear wall locations, and it's doing this in a way that actually maintains that same hierarchy. So it's designing for the load cases of the panel, of the module, of the building. It's also linked to the parametric model, so it changes as we update it globally, and it's also changing it locally too. So we start making moves there, and all these things add up. And again, this is all optimized. It's using robot structural analysis, so it's all validated structural design as well. And the output is a BIM model where we get kind of free LOD out of it without having to actually design that. And then the building has kind of a structural efficiency moving from the ground up. So this, as alluding to some of the things Magda mentioned as well, we're thinking beyond just the design phase, right? Like we've gotten a high level of design, but IC is all about getting it designed out of the computer and into the, onto the site, actually building it in the most efficient way possible. So we're already thinking about the file to factory paradigm, design connecting to manufacturing, connecting to production. But again, these are all opportunities to actually bring information back to the generative model. Like each of these steps has its own constraints and metrics. Those things can plug back into the generative model so that generative isn't just about design, but it's thinking about the manufacturing and the construction process as well. So I think this is where we're entering this kind of exciting new era of automation possibility. I want us to build models that have a lot of information in them, not again to make digital trash, but not to overwhelm the person on the shop floor who's nailing these things together, but because there are new agents and actors coming into the construction space. We have robots, we have new AI systems that are going to be participating here. And so, this builds on this idea that we've been building up technology. We've been kind of getting to where we are now by moving from parametric modeling, where we could start to record decisions, to generative design, where we have goals, constraints, and have exploration skills. And now we're in this space with generative AI, where we're seeing some exciting things happening in other domains, and it's coming to AC as well, where we can have systems that start to understand intent in models. Why things are the way they are, how things relate with each other, without having to ever be explicitly programmed about any of these rules. So again, this is kind of the simple example, but we're building all this high-level detail information. It's got a lot of rich data embedded in it. Maybe that's trash, but it shouldn't be trash, right? So we can actually have systems that are able to pull all of that and start to extract and understand those relationships. Even things that we might be missing, it might be hard to represent, that are kind of locked in people's heads, but design itself, actually building these models, encodes a lot of that information. And we're able to then turn that back into something that can generalize. So this is simple. We're seeing something that could be from a basic computational design system, but the idea is it's not just the wall. It's the wall as it relates to the floor, as it relates to the whole building, as it relates to the spaces it's bounding, and those things, having decisions about, do I need to use green border? I'm using drywall, for example. So the output, right? The output we have is, we're getting free level detail. We have kind of auto-completive designs, construction-ready detailing, but we're also getting assembly sequences. So, not only do we have that LOD model, but we know how to put it together. We know the tools needed to build each of the parts, and we're kind of matching that up because we're using multiple systems, multi-trades. We understand how to handle materials. This is a real big problem in the kind of robotic space, just how to even grip something and pick it up. We know the labor requirements. We're not just building these with robots and lights out factories, but there are people on the job site. We know the trades we need to have employed there. And then, material dependencies. We understand the relationships between, if I change the framing spacing, how does that change the insulation? How does that change the sheathing? How does that change all these kind of subsequent things that kind of cascade and that keep us from kind of fundamentally altering the way we build buildings? So that gets us to the point where, today we have these robots that are actually starting to do things on their own on the construction site. So these are some prototypes coming from the research side of robotic systems that are learning how to put pieces together. It's kind of baby steps here, but it's doing it just with kind of forced torque. So how it's feeling things out and it's looking at it, but there's no pre-programmed code to be able to put this together. And then the robots are training each other on this information. We can generalize this further into these assembly cells where all it takes is you give it a bill of materials and you give it an assembly final drawing where everything goes, and the system's able to scan all the pieces, figure out where they are, figure out how to get them there, how to pick them up. And again, the great thing here is these are all simulatable things, so we can pull information back to the generative model. So we can actually start to optimize design for this modality of construction. This isn't just a simulation though, it's happening in real life. And again, I think that the thing that's exciting here is not that we don't need robots to build these kinds of walls, right? Like these kinds of walls still could be built 2-3 times as fast by someone with a nail gun on a site and the chop saw, but it's starting to point to a future where if we represent enough about how things come together in the digital model, we can start to unconstrain the problem. We can start to design new construction systems, specifically around being able to use generative systems and use automated construction and really innovate in construction. So I'll end where I started, just to say, I think that the future is bright here. The technology is advancing fast, and it's enabling this new possibility in how we start to put things together. So I'll end here. Again, and just note, I would love to connect with everyone, to kind of reach out, see what we're doing in research. This is obviously just a single thread of work, but we're also in Industry Futures looking for kind of interesting, engaged partners who have these challenging problems that aren't quite served by existing software, existing technology, as an opportunity to kind of push the envelope and see what the future looks like. So thank you.
Our next speaker is Russ Willis, Director of Plant Operations at Modlogiq. Russ has been in the manufacturing world for the past 20 years, from high output production lines to one-off custom structural steel fabrications. Of the past 20 years, he has spent the last decade in off-site light gauge fabrication. He believes there is always a better, faster, cleaner way to build, and he focuses on how to get there. This is why he has invested the last 10 years into off-site prefab and modular building techniques. From researching automation, visiting plants, and having in-depth conversations with companies that use automated production floors, to breaking down labor analysis of non-automated factories, and everything in between. It is the driving force on how Russ and his team do what they do and what separates them in this ever-evolving industry. Russ uses a hands-on approach to leverage his knowledge and skills to uplift not only his products and their quality, but his employees' lives and company culture. Please welcome Russ Willis.
Thank you, guys. I want to thank Howick, obviously, for the opportunity, and Autodesk for hosting everything. There's a number of things I want to get to. One of the first things within the manufacturing world and doing things, I start with projects at the pre-construction side and run through into the installation. So there's a lot of misconceptions along where people want to be, what they want to do, how they want projects to start, and jumping right in. Everything that happens within construction is a big push on the details, especially with offsite. We have to be far ahead. Like Amr said, Faro Technologies is huge. They're great. They do a lot of scanning. Some of their scanners will run like 25 million bullet points in a matter of like half a second to give full read and full touch on everything. So all of that information has to make its way back into the design, into the build-up, and everything that goes along with that. Now, in those things, being able to leverage technology and use what's available into a bigger piece or a bigger section really depends on how you start the project and where the project starts. So in order to really kind of get successful in the manufacturing plant, you have to understand how you're manufacturing and what you're doing with that. The biggest first rule is do not model, do not start modeling, do not start creating anything until you have all the information. A lot of that information comes from where the project starts. Now, if it's owner-operator, designer, GC, depending on where you get involved, obviously the sooner the better. But getting involved, you have to ask the questions, are there models already set? Is there an architectural, structural, or MEP model? And then start to dissect that and break that down to what you can use. A lot of times, like what was mentioned earlier, those models, the architectural models, structural models, aren't worth using. They're not correct, they're not good. A lot of MEP designs don't take dimensions into account. So to be able to break all that back down and really start from the bottom and work your way through is where you need to do. With having the models, having everything set up, the biggest parts are the small things. What goes into the walls, having all your ROs, having your clearances, knowing what types of those instances, whether it's windows, doors, plumbing, electrical, ductwork, having all that set up beforehand. You can build that into the model. Having your model completely set up to hit go is not the most efficient, cleanest way to build. Within the data points underneath and behind your model, you can put the type of window, the brand, the model, the size, what your RO needs to be, what the blocking needs to be, the flashing details. If all that's in the data behind where the actual model sits, you can then reference that and use that into your shop drawings and how you create a bigger, more effective product. You can do that all the way into your drywall, depending on the type of the drywall you use. Screw patterns, type of screws, type of fasteners, everything you put into that, you can build that behind the information in the data. You can then take all that data, put it into your shop drawings. Once it hits the floor, your entire team knows what they need, what the screw pattern needs to be, and all your information is there on the shops. You don't have multiple different people pulling information from 50 to 500 different sheets of structurals within details, within all the different sets. There's really a lot of extra coordination on the front side that really pushes and leverages once you get into the manufacturing and how you do everything. One of the biggest advantages is being able to use it with your MEPs, knowing what your clearance needs to be around clash detection. Whether you're doing it on panels or prefab sections, all the way through full modular fabrication. You've got hold-ons, you have through-floor connections that you have to align, and you have to be perfect. When you are setting that up from scratch, you need to understand your clearances around everything. You can build all that into the model so you know what it needs to be on your shop drawing. You can pull those dimensions out, and your entire team from manufacturing all the way through install knows exactly what that needs to be because the information's there. It's not as involved on that side of things to really know where it needs to be. If you have the information in your model, you can take different types, whether it's Dynamo, there's a few others that you can do scripting. All that data is embedded in the model. You can do it behind the scenes as a data level, or you can do it within the different families. When you pull all that information out, it's easily scripted and set to go directly where it needs to be, and it's hidden in the model. When you view through, it's not there. You can pull it out and really get that streamlined process from start to finish, from details, information, materials, products, all the way through completion within your manufacturing setting. So having not just through floor connections, but inner wall and through wall clashes set up within your drawings, everybody on the floor, whether they're building it's a panel, it's a full finished modular, they know where that information lives, where it has to be, and what the clearance is. If the clearance is set up, it could be a square ductwork or a round ductwork. You know exactly what you have to have there. And between all the different information within the trades, whether it's ductwork, whether it's piping, you have all your different hangers and all your different attachment points that you have to have. Most trades, most tradesmen, tradeswomen, different people, and especially MEPs, they like using certain products. They don't like to just go, oh, this is what's designed, this is what's going to use. There's a lot of drawing intent that happens, and being able to model and quantify those different pieces, those different materials within your model, and have all of that material set on a material sheet that you can schedule out, they know exactly what they have. Bringing those teams in and those people in throughout the modeling and throughout the discovery phase really helps to push to give all of your team and everybody that's involved in it the ability to have a hands-on approach within being able to build that product, whether it's a wall or a full finished modular unit. Within Revit, they live within the different families. So building out those families before you start gives everybody the opportunity to really put their input in, have all your materials, have all your information, and being able to build in a more effective process. Now, one of the other big ones that's missed a lot is within blocking, not just window blocking or in-wall blocking for grab bars and that kind of things, but a lot of things on the exterior of the building. Whether they're adding buck hoist or they're adding hydraulic lifts and stuff to the outside of the building, all that should be designed within the model, and having those things already set so it doesn't show up to site and you have all of a sudden you have oh, how do we fix this? Or something's looking down the road. Having those things brought up in your discovery phase and knowing what you need to do really drives and streamlines the entire process to not only make sure the product is achieving that quality and what you need, but it's giving everybody else and setting them up for success on the backside of it. There's a number of different things that work out throughout beginning modeling and the discovery to where you need to have certain control gates. You need to have certain processes set up to where when you have your weekly or monthly meetings with everybody, they come in and you finalize all those different details, all those different pieces to really exemplify what you're trying to do, where you're trying to accomplish at the end of the day. There's countless numbers of projects that I've seen, read, and been a part of, to where you have best laid plans out, everybody's involved in going through, and you get to a point where things are starting to ship to site. Install crews don't know where they go, how they go, where they fit. And not only that, you have alignment issues. So it all goes back into the original detail and the design to be able to increase the repetition within stacking, especially with modular. When you're stacking 2, 3, 4, 5 stories up, you know each floor where your MEP closets need to be, where your connections need to be, where your through floor connections need to be. So as you stack on the prints, you have a bold corner or a shaded area that really outlines and sets everything up from a coordination standpoint. So as it goes to site and as you get set up and have everything going, before you get to the install, you have your coordination meeting with the installers. Within that, you lay out on your drawings, you have a bolted out or a cornered piece to really push to have the ability for them to see where and how everything fits. So once you get going and everything's there, you stack and continue on that same process. There's no guesswork, there's no questioning throughout the process of stacking. They are already involved in the layouts. You really cut time on the learning curve and the process of where it needs to go. The most important part of any and all offsite construction is your schedule. Now, having the schedule, the biggest factor of schedule is not just saving time, but also being able to drive the project and control the project from start to finish. The schedule, obviously up front, needs to be realistic, and you need to build your conditioning time within it so that as you get going and as you start, you're following the guideline that's already prepared and ready. So the project is easier to manage based on your control gates, based on your deadlines, based on your start and stops throughout the entire process. Now, when you get in and you have those certain deadlines, it helps keep the entire project under control and helps keep everybody really accountable from design to RFIs throughout your whole discovery and into production and timelines. That entire schedule really needs to be built upon every different act coming together and a cumulative effort of each different facet, each department, and each, breaking down from trade all the way up through shipping and logistics to really drive your timeline, drive your schedule, and keep everybody on the same page from start to finish throughout the entire project. There's many different things that come up from start of schedule all the way through where the end is. Fortunately, within the offsite, most, if not 90% of the work is being done within a controlled facility, and you don't have the weather delays and things like that. So you're able to get out 1 step, 2 steps ahead, getting started. One thing you can't control is your manufacturing personnel and your labor and things. There's a lot of question marks in there. One of the biggest things that have helped, and I found personally, within the manufacturing setting, having like an operations crew. That's kind of your jack of all trades. It's a very small crew that can jump in and run anywhere within the facilities, to where if you have certain call-offs, you have certain things that are kind of working backwards from your schedule in there, they can jump in and keep things moving and keep those dates and deadlines at a strong point. Once you get to the actual on-site and getting ready to ship, there needs to be a big set meeting with developer, on-site GCs, your install crews, your manufacturing team, to really go through the erection sequence. Having your erection sequence set is a fairly easy, fairly simple thing to really work through and get. But there's a lot of different factors involved that play a lot of, that play their hand in a lot of different things. Down south, you don't really have to worry about weather too much, but up in the north, especially here, you've got different weather issues, from permathaw, permafrost, when you can get into different things, when you can ship, what routes you can go, and going into the location, the area, what the local environment is, impact on the environment, where the crane can be set, the type of crane, the reach of the crane, where the trucks get into, where they set, and then the install crew, the size of space, the site space, crane permits, surrounding areas. If there is a hospital with life flight, or there's an airport in the area, you can't have certain crane heights or operate certain times throughout the day. Certain areas will have quiet hours, so you really have to sequence and set everything up before you get to the point where you begin shipping. One of the other strongest things is, once you get into production and you're working throughout manufacturing, getting to the point to ship, that train is started. You do not and cannot stop that train once they get going. Once you stop the train and you have to reset or make changes, then the biggest things that you look at, your speed, your quality, your efficiency, your cost to market, your cost to deliver, all that starts falling behind. And once those things fall behind, then the next step after your quality and your speed losing, you're losing safety. Now people are rushing. They're trying to get certain things set up and trying to get to a point to really go. So once you get started in production, to keep that going, maintaining the schedule, driving the schedule to a point to where you can really dial in and not have to pull back to reset, is really the main piece to keep your quality high, your cost on target, and everything else. Because as soon as the schedule falls, everything else falls behind it. There's a big number of projects and people that have gotten way ahead of themselves into modeling, starting design, starting drawings, and not fully understanding the risks that are coming in from not setting up the project correctly in the beginning. Having a certain aspect or a certain grasp on where the project has to start, what you're starting with, and where you're going to, really drives the entire project. If you don't have the time to really set it up properly in the beginning, to spend the time in the discovery page, getting all your RFIs set, getting the model set with the right amount of information in it, and creating the families to where you have the information, you have the material, you have your screw counts, you can pull all that back out within the scripting and set. You have labor times established then outside of your estimate. You can compare them back to your labor estimate. You have your material costs basically designed from the model, and you have that back-end control gate to get to manufacturing to really know where you stand at that third way mark. Because the design, the modeling, that's your 1/3 mark. After manufacturing, that's your 2/3, and then the site is your final and your wrap-up. So getting it started right in the beginning is really where the project is made or miss. Outside of that, that's really the big intent of my message today is in order to set a project up correctly through manufacturing, through shipping, it all starts in the details. It all starts in the design. If you aren't able or aren't willing to set the project up from the start, get the information you need, do not start modeling until all that information is there, and really allow your customers, your clientele, and the developers to fully understand that, yes, up front it might take 6 months, 8 months till you get to a point where you can manufacture, but that's what it takes to do it effectively. That cost savings, that time savings, that return on investment you're going to get at the end of the project all depends on that first 6 to 8 months. So that is what I've got for everybody. I wanted to keep it short, sweet. I know we're over time and past time, so that's what I have. Thank you, guys.
Without further ado, I am very excited to announce our last amazing speaker to close us off on this fantastic event, Hamish Coubray, the director of Howick. Hamish Coubray is the general manager of roll forming services and director of the Howick Group, of which RFS is the product manufacturing arm. He is third generation of the family-owned business. A mechanical engineer by trade, he has been involved in all aspects of the Howick Group business since he was a teen, from machine assembly and manufacture, training, installation, and technical support, to product development, business development, and management. Hamish's passion for always seeking a better, more efficient way to do something is perfectly suited in the construction industry, where there is so much opportunity to break away from the status quo and do things differently. By asking questions like, how can we do things better and smarter, Hamish has proven that when you push the boundaries, think creatively, you can consistently deliver a practical, commercially viable, better result. Please welcome Hamish Coubray.
This afternoon, I'm going to talk to you about how we've been putting into practice an idea about compressing timelines using expanding frames. When we go downstairs later on, you'll see this beauty down there. This is our Extender 3600 machine, which is a telescopic framing machine. This machine, we were around about early 2020, we were about to release this into the market, and then it got delayed a couple of years, obviously, where everyone was stuck at home. The initial machine that's supposed to come up here stayed in New Zealand, and we put it into Roll Forming Services, our local manufacturing arm, and decided to play with it. We've added another one since then, so we're running 2 different sizes. Kind of the idea came about because internal structures are never perfectly square or level, and how do we more easily overcome the as-built environment? When you're working with extremely accurate manufactured panels, how do you make them fit in a space that is not built to the same degree of accuracy? So imagine you could design a panelized interior wall system that could extend upwards, outwards, easily fit an uneven ceiling, or match up to a column that's not perfectly square or where it should be as the design says. At the same time, with internal bracing, keeping all the studs perfectly plumb, and being able to add in details like accurate and square door frames, openings, additional studs for corner details, and plasterboard fixing, or anything else that you might need to add into that structure. So what is a telescopic panel? A telescopic panel is made up of 3 components, a C-stud, a ribbed internal stud, and a U-track if a deflection head is required. These panels can be made with any combination of these configurations, and they all come out of a single machine, either panel by panel to be assembled to go panelized to site, or as batches of like components. So there you can see the C-stud and the R-stud. So the R-stud is smaller overall dimensions to slide inside the C-stud to give you that adjustability. And then also a U-track if it's required to do a deflection slot on the top. Here's a quick little overview of how the process works. You'll see it again downstairs, but basically the approach of panelizing the telescopic framing is really similar to traditional panelized steel framing, except we add these extra components in for that adjustability. So you can adjust for a small amount or a large amount if you're limited by access to a building. And here you can see us bringing small panels in through a doorway and just setting them up to fit the space that's there. Okay, and it's that easy, hopefully, every time. So there's quite a few advantages in using this system for non-load bearing walls. I won't go through all of them, but time, which everyone needs more of, is probably the biggest factor in installing these panels, getting them in, and making them fit. So the extended framing started out as a kind of a simple panel idea. Here you can see an early project we did, which is just full high walls with deflection tracks on the top, telescopic studs at 2-foot centers, and in the front there you can see the standard kit of parts that they used. So as an example, you could design a standard panel 10 foot long that can adjust between 8 and 11 feet. That can be flat packed. The top and bottom tracks are both U-tracks, so you can place additional studs where you need them if you want. But very quickly it escalated because everyone wanted more detail. And one of the first projects we did in New Zealand on a large scale was this, Victoria Lane Apartments in Wellington. It was a new build, structural steel frame with tray deck concrete floors, concrete elevated shafts. And this project was the top 12 floors of the 16-level building, which was 100 high-end 2 to 4 bedroom apartments, many of them with differing layouts. So each level was done in 3 stages. First, we did acoustically rated corridor wall. This consisted of 3 5/8 top and bottom tracks with deflection header on the top, 2.5-inch studs staggered at 1-foot centers, also telescopic to reach the slab above. And you can see a close-up of how they worked. We also only punched the dimples for the bottom connection on the side where the stud was supposed to go according to the design, so they didn't mess it up. Next were the intertenancy walls, 2.5-inch stud walls with 2-inch air gap between them. Again, telescopic with a deflection header and telescopic on the ends to meet up with the outside of the structure and the corridor wall. These also had diagonal braces in them to keep them square. And here you can see we also added an additional nog near the top for the plasterboard fixing to allow the deflection head not to be interrupted by screws. We also punched additional holes below the bolt holes for fixing to the slab above so they could easily access through with a long bit. And then each apartment fixed height walls with a false ceiling. These were telescopic to the outside parts of the building, to the IT walls and to the exterior of the structure. You can also see on the plan there the little telescopic symbols showing where we had horizontal adjustability. And we also hosted each one of these models that you just saw on a web-based 3D viewer, and we linked these by QR codes on every drawing. So anyone on the site could scan the QR code for each stage or the entire model and easily see how the frames interacted, how they connected, which way the bracing was supposed to go. So if they couldn't fully understand the 2D drawings, they had a 3D model to access really easily, and they could look at it. We also hosted standard details for some of the connections the same way. So the guys on site could easily avoid ringing us to ask questions by looking at a model. Oh, here's a little video of how 3D model worked on the viewer. So you can see we color-coded the floor plan as well so they could see which way the frames overlapped, and they were all labeled according to the panel. This project was the first project with this client. They're a large contractor. They hadn't used this product or, in fact, any panelized wall framing system before. It was around 220,000 feet of framing. This was flat packed and assembled on site because it was about 10 hours by truck to the site, so it was just more efficient to do it that way. And they came out of it at 50% of their budgeted man hours compared to stick framing it with stud and track. So for the first project with that client, it was a huge success. And we've gone on to do a few more, a couple we're doing at the moment. Here's another project we did with them when the architect asked if we could do a curved wall for one of their projects. I said, sure. And this was the design in the end, which was more than one curved wall as I was expecting. And as you saw in Scott's presentation, we can design a curved panel by overlapping punches with our standard tooling, which is available in all of our machines that are sent out. So anyone that's got an existing machine can add this into their repertoire of design. Here you can see on the right, full height curved wall, which is telescopic, also has a door frame in it, diagonal bracing, and then it has horizontal telescoping to the facade of the building to take up that slack. And here's a couple of other current projects we're working on with the system. So this is 1 Queen Street. This is in downtown Auckland. It is a concrete structure built in 1972, and they stripped it back to the superstructure, point cloud scanned it, and went from there to design a modern, energy-efficient building. They're saying there will be about 50% of the embedded carbon emissions compared to building a new structure in its place. So this project, we are doing the top 6 levels, which is office fit out. You can see kind of the step in the building from where we started there. It is cast concrete construction with double T's. So here you can see a nice little picture of what we did here. We did prefabbed infill panels for the double T's, which they installed a 10-foot section in about 2 minutes. And then we had telescopic framing coming up underneath to meet it with the deflection header to allow for vibration and movement in the floor. Another one is the New Zealand National Archives building in Wellington, which is an interesting one. This building, we are doing all the bulkhead fit out. So there's a really high fire rating requirement because it's the National Archives. So we're using telescopic panels to infill around all the structural beams in between the floor decking, that concrete decking system, to allow for their fire rating. And there's a couple of the standard details of how those bulkheads all fit in. We're also doing some load-bearing telescopic framing. So these are fixed height, but horizontally telescopic to fit in with an existing concrete building with ceiling panels above, with MEP above the ceiling panels. And that's it. Thanks, everyone.
Thank you so much, Hamish. Hang on just a second. Any questions for Hamish? There are a lot of really great examples of how the Howick is being put into work. Okay, we've got one right here. Yeah. The question was, is there a situation where it's more efficient to bring the machine to the site?
Yeah, there can be if it's a remote application. The project, the VLA apartments I showed you at first, it would have been nice to ship the machine down to the site there. That was in the middle of COVID, so we weren't allowed to leave Auckland, but the trucks could. So in that case, it would have actually been a better option to send the machine down and assemble down there. So we would ship the kit of parts, wall by wall, wrapped together, bundled, and they would put them on each level where the panels were to be installed, and they would assemble the panels on that level and then erect them. And what the guys found in doing that is the guys that were installing the panels could leave their apprentices and labourers to assemble the panels because it's a kit set of parts and they could follow the drawings. So they could focus on installing them, and the labourers and the apprentices could build the panels for them, and that worked really well for them.
You have to infill with steel framing. Actually, in this building that we're all in today, we dealt with it. And I'm curious, when you do the scan, like the guys, when we do it, they just cut it here and they kind of fill, and as you know, they're all slightly different.
Yeah.
When you use a scan, how much are you customizing that to address the conditions in the field for each partition?
So for each partition, well, we are generally allowing about 2 feet of adjustment, so plus or minus 1 foot of adjustment vertically, and more so if there's constraints in getting it into the building. So we allow a lot of adjustment to take that out of there. It also reduces the design time, so you're not making all different height walls all over the place. So if we had a 6-inch variation in the ceiling height, we could design all the walls to sit 6 inches below the lowest height and have enough adjustability to reach the highest.
Okay. All right. Thank you so much
No
again,
problem.
Hamish. I really appreciate it. I'd just like to say thank you and congratulations again to all of our amazing presenters. That was fantastic. What an amazing just mind meld of everything that we've been learning about with industrialized construction. So thank you again so much, everybody.